Okay, so thanks very much, and thanks also to Elisa for arranging this and giving me the opportunity to explore again, continue exploring some ideas that I want to try to develop. Before getting to today's topic, which is mainly going to be sort of introductory and setting up, I want to say something more generally about what I want to try to do over the next today and 4 more days. It was 50 years ago, really fully 50 years ago, that I first wrote about conditionals, and I've been thinking off and on about them ever since. I tried in the first paper published in 1968 to solve a problem, but solving a problem is really not quite the right word for it, since it's really still not solved. There are many problems, and one hopes that that we're making progress in the sense of deepening and clarifying what some of those, sharpening what some of those problems are. But the deepening brings on more problems, and there are plenty still remaining to work on. The focus today, during most of the sessions this week will be on counterfactual conditionals, not on so-called indicative conditionals. But we'll spend give some attention to that, partly because I think one of my sort of themes is that the indicative conditionals are, in a sense, more basic, more primitive, and it's a development from them that leads to counterfactuals. And that there are sort of distinctive problems for each kind of conditional, and the differences between them, as well as the continuities between them, I think are helpful for trying to understand them. So today I'm going to talk some about indicative conditionals in a little bit, but the main focus will be on trying to get clear on counterfactuals. I should say just a remark about the grammatical terminology that has traditionally been used to distinguish 2 kinds of conditionals, called indicative and subjunctive. But for several reasons, these even linguists have gotten used to this distinction, even though it's really not accurate for several reasons. I remember when I first gave a talk years ago, back in the 70s, in Sweden, where people studied English grammar in the way English speakers don't ever study it. And they were puzzled because these aren't indicative. This isn't indicative and subjunctive. But the terminology has stuck anyway. So one reason why the grammatical distinction is not quite right is that the ways in which the distinction is marked in different languages is different. So in particular, I don't know what it's like in Italian, but it's probably more similar to French than it is to English, I assume. In French, I know there's a special tense, so-called tense, called the conditional tense. Whereas and the subjunctive is used for something totally different. In fact, some conditionals, archaic conditionals in English that are, strictly speaking, grammatically subjunctive, fall in the category of the indicative as far as the philosophical distinction or grammatical linguistics distinction is made. So when Patrick Henry said, if this be treason, make the most of it. Of course, that's a conditional imperative, but you can construct with the be, which is a distinctive mark of subjunctive in English. You can construct straightforward conditionals, which are epistemic conditionals, or meet all the conditions of indicative conditionals, even though they're in the subjunctive, although that's archaic. The main distinction in English is marked with tense, not with mood. And the would, which is distinctive of English so-called subjunctive conditionals, is in effect, so morphologically, a past tense of a future modal, because will is a modal word which is used to express the future. We don't have a future tense, strictly speaking. And it's interesting that in different languages, including French and I understand Greek, there's something like the paradoxically sounding past of the future, marked in different ways, but it has that feature in both. So in French, the conditional, so-called conditional, is a imperfect past tense ending on a future tense stem. And in Greek, they do it a different way. And in English, we have a past tense of a future modal. It's a complicated grammatically, but the distinction is functionally relatively clear to make, even if it's marked in complex ways in the different languages. So I'm going to continue to use the terminology indicative and subjunctive, but it should be understood in this not entirely grammatically correct terminology. Okay, so the lectures will be exploratory. I'm going to argue for a certain approach to the problem, and for argue against certain other strategies for addressing the problems, and be concerned both with some more methodological issues and some more substantive issues about counterfactuals. But mainly, I'm going to bring out as many problems as I try to solve. Okay, so today I'm going to talk mostly about the contrast between the two kinds of conditionals and potential connections between them, and in particular some of the problems with so-called indicative conditionals. Tomorrow I'm going to look specifically, spend the time on a certain philosophical strategies of analysis, which I'll talk a little bit at the end today, the reductive strategy, that is the strategy of trying to give a reductive definition, or to take some philosophically problematic concept and reduce it or analyze it to unproblematic notions. So that was the traditional empiricist strategy for dealing with counterfactual conditionals, a strategy that David Lewis developed in a quite different form. And so I'm going to contrast Lewis's strategy. Lewis's analysis, formal abstract analysis of counterfactuals, is very similar to mine, but his sort of philosophical foundations for the defense of a theory of that kind is radically different from mine. So I'm going to sort of focus next time on Lewis's strategy, and more generally the sort of issue of reductive analysis, and argue against it, argue that it's a failed project, and in fact has mixed motivations that don't fit together very well. Wednesday, I'm going to ask, so if we can't give a reductive analysis, what do we do? What's the alternative? That is, how does one approach a philosophical concept or a family of philosophical concepts that one finds problematic in some sense, but that are not reducible? In the same time Nelson Goodman was first writing about counterfactual conditionals in the 1940s, Roderick Chisholm wrote a paper with very similar arguments about independently about the same time, arguing against certain reductive analyses, and his sort of conclusion in the end was, well, I guess they're primitive. End of story, right? He said, but somehow the idea that either you can reduce something or you can't, and if you can't, it's primitive, and so we just buy it and move on. So there's got to be some way to approach a philosophical problem other than to provide an analysis. There better be. Many attempts have been made at philosophical definition, reductive or limitative definitions. Few have been thought successful. When you look at the history of the analysis of knowledge in terms of justified true belief plus some little addition that takes care of all the Gettier problems, and that was an enterprise that went on for quite some time until people pretty much gave up on it. But one's got to be able to say things about, it's not that one says, okay, so knowledge isn't a problem after all. So we have all kinds of arguments for skepticism and various things which show that we need some kind of clarification of the concept of knowledge and its relationship to belief and other notions. And if we can't give a reductive analysis, what do we do instead? So I'm going to focus on Wednesday at a certain strategy. It's a very impressionistic and general strategy, but I'm going to try to suggest ways it can be developed more precisely, which is a strategy of attempting to address what's problematic about the concepts without analyzing them in a reductive way. Even if we don't reduce conditionals, we're going to look at the function that they serve and at the role they play in addressing practical concerns. So a lot of the emphasis is on, in the first way of developing strategy, on the epistemic role of counterfactuals. What role do counterfactual claims play in epistemic reasoning? Because the indicative conditionals are explicitly ways of expressing certain epistemic attitudes. Counterfactuals are more distantly connected, but are still connected to epistemic attitudes. So one of the roles or functions of conditionals, well, let's talk about, are epistemic, but we're also counterfactuals have a very direct connection with practical reasoning, or reasoning about what to do. In deciding what to do, you compare what will happen if you do what you're planning to do with what would happen if you did something else instead. You may know for certain that you're not going to do certain things, which only a nut would do. But still, they're open to you, and you want to explain why it would be crazy to do those things. And in doing so, you say, what would happen if you did? So counterfactuals play a clear role in practical reasoning, and various formal ways of trying to clarify practical reasoning, including Bayesian decision theory and particular game theory, involve implicit assumptions about causal and counterfactual structure. So we have some formal theories which concern the application of counterfactuals, even though they don't explicitly aren't developed by appeal to counterfactuals. But the formal theory raises some questions, and which a theory of counterfactuals helps to answer, and also the theory of counterfactuals raise problems which are sharpened and clarified by looking at their application in decision theory. So I'm going to spend some time in the fourth lecture on developing and pointing to the sort of counterfactual, implicitly counterfactual assumptions built into the theory, and then at some of the ways in which the different kinds of sort of dispositional notions involved, which have to do with the difference between practical and the knowledge by discovery, by evidence, and so on the one hand, and knowledge by decision on the other, a decision that's crucial to the decision theory and game theoretic framework. So we're going to look at the practical issues, I mean not practical in the sense of having to do with action and decision in the fourth lecture. In the fifth, on Friday, I'm going to focus on dispositional properties. The original thought was, if we had a nice analysis of counterfactuals, original thought which motivated a lot of the early work in the positivist and philosophy of science tradition of the 30s and 40s, was the attempt to clarify theoretical concepts in science, and the dispositional properties, dispositional predicates, were kind of paradigms of the simplest kind of decision that goes beyond direct evidential experience. So it was thought that if we had a nice analysis of counterfactuals, we could explain dispositional properties. But the project of trying to find an analysis of counterfactuals, at least a reductive analysis, didn't succeed. Nelson Goodman later suggested maybe dispositional properties should be approached directly, rather than, maybe the problem would be simpler than the problem of analyzing counterfactuals. And I think there's something right about that view. So I'm going to look at the general problem of dispositions. Along with thinking that maybe they're simpler, part of that was an argument that dispositional properties, in fact, can't be analyzed in terms of counterfactuals anyway. So there are various counterexamples to a counterfactual analysis of dispositional concepts. There's obviously some connections between dispositions and counterfactuals, but what the connections are is less than any attempt of reducing one to the other. So I'm going to look at the general questions, some general questions about dispositional properties and the way they fit into the general strategy I want to defend. And then tying in with the issues about practical reason, I want to look in particular at some dispositional properties of human rational agents, which are connected with evaluating their actions. So the two kinds of, well, there's many kinds, but several kinds of dispositional properties connected with rationality. There are, in the theory, probabilities and utilities representing degrees of belief and degrees of desirability or something like that. So these are properties about what of a belief-like kind and of a desire-like kind. But there's a third kind of dispositional property that's involved in action, and those are intentions. Intention maybe is a kind of belief, some people argue, and it's grounded in, perhaps in some sense, in your desires or your values, what you value. but there's something independent or separate about a decision to do something. It isn't just a direct application of the motivational state, but there's sort of a move of forming an intention to do something, and therefore coming to believe that you will do it. So intentions are a distinctive kind of dispositional property. And in the game theory, you have a notion of strategy, where a strategy is like a complex conditional intention, or at least that's one way of understanding what it is. So I'll look at the idea on the last day of strategies in a game, or strategies in a decision problem, a complex sequence of decision problems, as a kind of dispositional property. In all this, we're going to find there's a family of concepts that Hume grouped together under the natural necessity category. A family of concepts which have conceptual connections between each other, and even if we can't find a reductive analysis of something independent, we can perhaps explore the territory of the relationship between these different concepts. Okay, so that's what we'll do on the last day. So conditionals generally, as a topic, form a basis for connecting a range of totally different areas of philosophy. So the issues are metaphysical. I mean, of course, there's lots of semantic issues and issues about meaning and compositional structure and so on involved in the logic of conditionals. But the original problem of counterfactuals is really a metaphysical problem, even though the positivists and logical empiricists who developed the early work in this didn't want to think of it as metaphysics, but it has to do with, it's metaphysical in the sense that what kind of claim about the world do counterfactual conditionals make? What are they saying about the world? And again, the reductive strategy is one that says we can reduce the apparently extra stuff that is said about naturalness, the natural necessary connections between things. We can reduce all that to something more basic. But the anti-reductionist strategy is saying, no, there is our conception of the objective world essentially involves these kinds of connections. So there are metaphysical problems about conditionals. There are definitely epistemic, the epistemic role of conditionals is on the forefront with indicative conditionals, but there in the application of counterfactuals as well. Third, practical reasoning, moral psychology, whatever you want to call it. These issues are essentially connected with conditionals as well. So we'll look at some of the interaction between those different things as we go. Okay, so today I want to start by exploring two interconnected issues. And the two issues are, first, and this is on the handout. The handout starts with a minimal pair to illustrate the contrast between the indicative and subjunctive conditionals. And this is the original pair of this kind was due to Ernest Adams. This example is due to Jonathan Bennett. If Shakespeare didn't write Hamlet, someone else did. Obviously true if conditionals have truth values. But obviously appropriate to say. The play Hamlet exists. If Shakespeare didn't write it, somebody did. It didn't just reappear out of nowhere. Everyone will agree with that. The counterfactual, if Shakespeare hadn't written Hamlet, someone else would have, presupposing that he did, but imagining a counterfactual situation which he didn't. Here, some people would say this is not only false but impossible. That is, it's essential to a play that it's written by the person who wrote it. Was it Borges who wrote a story about somebody else writing Don Quixote, I think. Yeah. And word for word the same one, but many people would say, no, it's not the same, it's a different one. And you could imagine someone writing Hamlet word for word or something like it, but it wouldn't have been Hamlet, it would have been a different play, since the origins of a play are essential to it. So, but whether you think it's a necessary truth or not, a necessary falsehood that someone else would have written it, it's at least radically implausible that someone should have written a play word for word like that if Shakespeare hadn't written it. Okay, so we have a clear contrast, and it raises or helps to raise two questions, which are the second thing on the handout. What is the relationship between these two kinds of conditionals? Should we give a unified analysis of conditionals with an explanation of the difference between them, whatever it is, exactly however it's explained, a difference as created by some other difference involved in the interpretation? That is, could we say there's a uniform abstract analysis, but two kinds of contextual parameters which play a role in determining the truth conditions relative to context, which yields a difference, but the difference is within the context of a unified theory. So that's one question. Should we give a unified analysis, or should we say there are two kinds of conditionals? This one should be analyzed this way, this one should be analyzed that way. So that's one question. A second question is, the interrelated question is, do indicative conditionals, well, generally, do conditionals express propositions or have truth values, or are they to be explained in some, as a different kind of speech act? You can ask this question about indicative conditionals, and you can ask this question about subjunctive conditionals. You can give the same answer to the two questions, or you can give a different answer, and that's where the connection comes with the first question. If you give a unified analysis, then you're going to give a unified answer to this second question. Okay, so whether either or both kinds should be addressed, I mean, you think of a conditional as a distinctive kind of speech act that involves just two propositions, the antecedent proposition and the consequent proposition. Then what the conditional does is used to perform a conditional speech act of a certain kind. But you can address not just speech acts about conditionals, but also conditional attitudes. So should you think of, if you think of someone believing a conditional, an indicative conditional in particular, do you want to think of this as a case of, first of all, let's explain what the content is, the propositional content of the conditional, and then say believing it is having the belief relation to that proposition. So one could give a unified account of belief and other propositional attitudes, and as attitudes taken toward a certain propositional content, so the task of explaining a conditional attitude is the task of simply applying an attitude to a certain kind of proposition. Or you can think of there being distinctive attitudes of which don't take a single propositional content but a pair, and express some attitude about the relationship between those pairs. So in particular, particular, conditional probability, where probability is understood as degree of belief, is a doxastic or belief-like attitude, which you need to explain in terms of the relationship between two propositions. On some most straightforward applications of probability, a conditional probability is defined in terms of absolute probabilities. It's a ratio of the two, but it's not defined in terms of a probability of a proposition of any kind. It's the kind of thing that gets an absolute probability. Okay, so that's the question. The one question. So I'm interested in one of the reasons I want to try to connect. One of my sort of motivations for looking for a unified analysis for answering the second question in a uniform way is that I'm interested in whether the relation between the two kinds of conditionals can help us to use each to clarify the other. Second kind of question I'll be interested in is what's at stake in the debate between the debate about whether conditional statements have truth values. I mean, there's a question whether, as I say, we're interested in the metaphysical question of what does a conditional tell us, what kind of claim does it make about the world? But the very idea that it makes a claim about the world is itself subject to debate. Even the ardent defenders of a non-truth conditional account of counterfactuals, such as Dorothy Edgington, the most sort of prominent defender of the no truth value view of both kinds of conditionals, wants to say there's something objective about the world that a counterfactual expresses. So the metaphysical question will still arise, but I think it's the clearest motivation for a truth conditional account that it helps to make clear what that objective feature of the world is. Now, it's well established by our first example of a minimal pair of conditionals, the Shakespeare example, that there is a semantic difference between the two kinds of conditionals in the following sense. To say there's a semantic difference doesn't mean they get a separate semantic analysis. It means that they may get the same semantic analysis with a parameter which determines a different proposition, if it's a propositional analysis for the two cases. But there's a clear semantic difference in the following sense, and again, this is neutral between the propositional and the non-propositional ways of handling the examples, is that the difference between the two kinds of conditionals in some cases are cases where the same propositions seem to be expressed by the antecedent and the consequent of the conditional. That is, Shakespeare didn't write Hamlet, and someone other than Shakespeare wrote Hamlet, or someone other than, someone other than Shakespeare wrote Hamlet. These are propositions that seem to be the same, expressed by the antecedent and consequent of both the subjunctive and the indicative conditionals in this pair. So the component parts express the same proposition, but it's clear that, to put it in a more neutral way, that one of them is assertable and the other is not. One of them is assertable and on some theories true, whereas the other is appropriately denied and some would say false. So that's a common ground for everybody in this dispute, but that's where the agreement stops. Some theorists would give separate and independent analyses of the two kinds of conditionals. So just to give some names to this strategy, Alan Gibbard has gone so far as to say that the linguistic similarities between the two kinds of conditionals is, quote, little more than a coincidence, unquote. Gibbard wants to give a non-truth conditional analysis of indicative conditionals and a propositional analysis of subjunctive or counterfactual conditionals. David Lewis, who famously defends a propositional analysis of counterfactual conditionals, also wants a propositional analysis of indicative conditionals, but a different one. In particular, he defends the material conditional analysis of indicative conditionals, arguing for a pragmatic, kind of Gricean explanation for the facts, the paradoxes of material implication, the facts that it's inappropriate to assert them on the basis of the falsity of the antecedent. Okay, so that's the Lewis view, and his account of the subjunctive is similar to the one I want to defend, although not exactly the same, what he calls a variably strict conditional analysis, a modal analysis, in terms of that it says roughly that a proposition is, counterfactual proposition is true in a given possible world if and only if the consequent is true in all of the nearest, in some sense to be explained of nearness, possible worlds in which the antecedent is true. Okay, others, including both Dorothy Edgington on one side and me on the other side, arguing for some kind of unified analysis of where the difference between the two is, as I said, explained in terms of difference in a parameter. Now, the two issues, whether conditionals of either or both kinds express propositions and whether the two kinds of conditionals should be given some unified analysis, are connected in the following, at least in the following way. The case for the no truth value analysis for the conditional, the expression of conditional belief or conditional assertion kind of account is strongest for indicative conditionals. The extension of the no truth value or no proposition analysis to counterfactuals is much more difficult and convoluted. But both Dorothy Edgington and earlier Ernest Adams still wanted to defend a non-truth conditional analysis of subjunctive conditions. So the case is strongest for the indicative, whereas when one turns to truth conditional analyses, even though there are lots of problems with pinning down the parameters you need to interpret conditionals, at least the sort of intuitive plausibility of a proposition analysis for counterfactuals is much more straightforward and stronger. It seems clear intuitively that a counterfactual, even though it may vary, it may be context dependent in many ways, it aims to state a fact about the world. It aims to say something about dependencies between facts in the world, something that could be true even if we were wrong about it, in the way in which there's a distinction between truth and falsity on one hand and justified and unjustified, reasonable and unreasonable on the other. which is sort of stock and trade of a kind of realist view of language. Right? To say whether something's actually true is a different question than whether one has good reason to believe it, with with divergences on both sides, both things that are false, but because of misleading evidence, reasonable to believe, and things that are true, but because of misleading evidence, unreasonable to believe, or the absence of evidence in that case. So that's an obvious distinction. It's a distinction that one wants for counterfactuals, and Dorothy Edgington would agree one wants it for counterfactuals. Some distinction between what's correct in some sense and what's justified or reasonable. Something that motivates a more objectivist view of a propositional view. So sort of the default position is truth conditional about counterfactuals, non-truth conditional about indicative conditionals, and the defense of the unified theory requires different work for the truth value people and the non-truth value people. The reason a propositional analysis of indicative conditionals is problematic is, as we'll see, and we'll look at some examples, the indicative conditionals are not just context dependent, but extremely fragile in the sense that change the context just a little bit, change the epistemic situation of a speaker or the speaker and the common ground of a speaker and addressee, change it just a little bit, and the truth conditions for a truth conditional analysis change. So when you have extreme dependence on local contextual facts, you get a truth conditional analysis which doesn't yield a kind of stable object, a stable proposition that you can take away from the context and say, well, one of the things I learned when somebody asserted this conditional, I learned a certain fact which I now can take away and apply in other contexts. So one could ask, what's the point of a truth conditional analysis if it doesn't yield stable objects with which we can describe the world? So that's an issue which sort of pushes toward a non-truth conditional analysis. Okay, so I have, when we look at the question about indicative conditionals, over the years I have been on both sides at different times of this issue. So I originally defended in the 1970s an analysis, just an application of the analysis applied, motivated mainly by counterfactuals, with a particular contextual assumptions to explain the distinctive features of indicative conditionals. But I found Alan Gibbard's arguments against a truth conditional account very persuasive, and later argued that at least in a book, Inquiry, at least there's no detachable proposition, nothing that sort of can be detached from the context. So sort of suggesting a kind of non-truth conditional analysis was the best one. But since that variation, it's now my settled view that both sides is the place to be. So my hope is that we can bring the two kinds, and this is what I argue in the paper that some of you read, called indicative, or rather conditional assertions and conditional propositions, that we can bring the two kinds of analyses together and to show, this is an ecumenical strategy, but to show that there's less difference between between the two analyses than there appears to be. In the end, I want to stick with the idea that the context dependence with indicative conditionals, at least in many cases, is extremely fragile, and we don't get anything stable to take away. That is, if you look back later, after a debate in which two people made, say, contrasting indicative conditionals, and ask who was right, in some cases the answer is that question no longer arises. We can't now, we're not in a context anymore where we can express that, those propositions. They were local in a certain way. But that doesn't apply to all indicative conditionals. And I think it's the motivation for sticking with the proposition analysis, and I think it's important to try to bridge the gap between a conditional assertion and a propositional account, and to find some continuity between the transition from one to the other. This is partly in the interest of clarifying the relationship between indicative and subjunctive conditionals and seeing how we can use the sort of epistemic features of an indicative conditional to help clarify the criteria for evaluating or assessing counterfactual conditionals. Okay, I'm running short of time here, but we can give, as this is on the second page of the handout, just to sort of sketch the idea of a specific conditional assertion account and a specific, more specific propositional account, and pose them within a common framework so that we can look more precisely at the relationship between the two kinds of analysis. The idea is that the speech act, this is again top of the handout, the speech act of categorical assertion is a proposal, this is on the sort of looking at the speech act side of it, a proposal to change the context represented by the set of possible worlds in the context set, which is the possibilities compatible with our common background presuppositions, to change it by adding the information that the content of the assertion, which is the content of the assertion, to the context. So this is the sort of classic context change analysis of assertion in a proposition, for a categorical assertion. And you say, when you have a conditional assertion, you begin with an assumption or supposition. You don't assert, you add the antecedent to the context, not on the basis of asserting it, but rather simply asking you to suppose it. So it's a temporary supposition. That creates what's sometimes called a local context, a temporary local context, and then in that context you assert the consequent, eliminating the possibility in the same way you would with the categorical, but in the derived context. So it's like sequester the possibilities incompatible with the antecedent to create a temporary context, make the assertion in that context, and then add the original ones back again. The effect of this is exactly the same as the effect of asserting a material conditional. And that helps to explain some of the close similarities between assertion with certain hypothetical qualifications. The assertion of an indicative conditional is very similar to the assertion of an indicative conditional. But the Speech Act account explains it in a somewhat different way. And in particular, it doesn't apply. You can't assert, make a conditional assertion on the basis of the false belief in the falsity of the antecedent. So it helps to explain the differences between indicative conditionals and material conditionals at the same time as explaining the closeness of them. So that's the kind of then added to that, to tie it in with the notion of conditional belief, is the defenders of conditional assertion, kind of like Dorothy Edgington and Ernest Adams, argued that in general, the assertion conditions for a categorical assertion are the probability of the content is high. So if the probability of the content is high enough, depending on your assertion context and so on, then you're justified in asserting it. Similarly, if the conditional probability is high, then you are in a position to assert make the conditional assertion. Ernest Adams went on to develop a logic of the conditional on the basis of the conditional assertion account, where the rough idea of the logic was a conditional inference is a good inference or a sound inference if by making the probability of the premises high enough, you can always raise the probability of the conclusion to as high as you like. So you make them as high as you want, less than 1, and you can make the conclusion, so the argument is valid just in case you can do that for that argument. The probabilistic account of validity that Ernest Adams gave coincided with, extensionally, with ordinary validity, truth conditional validity, for the case where the premises all express propositions. But in the case where some of the premises are conditionals, which don't express propositions in his account, you get a notion of validity that doesn't where the truth conditional one doesn't apply. Okay, so that's the sort of rough idea of the truth conditional analysis. The rough idea of the propositional analysis, which we'll look more at later, is that on my version of this account is you interpret the conditional relative to a selection function which selects for each pair consisting of a possible world and a proposition, suggests a world which is intuitively the way things would be if the antecedent were true. That's to put it in a kind of circular way, but that's the idea. And the aim of the proposition, and then the conditional is true, just in case the consequent is true in the closest world in which the antecedent is true. For Lewis, it's a set of worlds rather than a single one, but otherwise close to the same idea. Now, on my way of understanding the abstract propositional analysis, the aim was not to reduce counterfactual conditionals to something more basic, any more than a Kripkean account of necessity as truth in all possible worlds is a reduction of modal notions to non-modal notions. What are possible worlds? On Kripke's view, they're counterfactual situations, they're ways a world might be. One uses modal notions to explain what possible worlds are. So what is the point of such an analysis? Quine was quite scornful of this. He thought, I thought we were supposed to understand what counterfactual situations were by doing this semantics, and here you're using them to say what your formal apparatus is. But the aim was to bring out and clarify the abstract structure and the logic of conditionals, not to reduce them to something else. So explaining necessity as truth in all possible worlds helps to clarify why the quantificational structure, the parallel with the relationship, dual relationship between existential and universal, corresponds structurally to the correspondence between possibility and necessity. there's more to it than that. And interaction with quantifiers is part of it, but the analysis can clarify philosophical problems even if it's got this sort of circular element to it. So the aim was to give a really overtly circular, in a way, in terms of the problematic nature of the concepts involved, analysis, but one that revealed the logical structure of counterfactual and other kinds of conditionals. So the further project, it's our way of setting up the further project of saying, so what do we mean when we talk about the nearest possible world or a nearest possible world? What does it mean? Well, don't make any gratuitous changes. Find a world which leaves everything the same as much as you can. Well, what does that mean? It turns out, as Goodman's analysis revealed early on, before all this, you can't change anything without changing all kinds of other things, and we need some kind of criterion for doing that. Goodman gave up on finding that criterion, Lewis, and thought we could give a further reductive explanation of that. Okay, if I have time, I mean, again, this is all just kind of trying to set up, and we'll talk more about the details of these analyses in the next few days. But I wanted just to end with citing the traditional strategy in general for explaining a philosophical problematic concept. The strategy was, again, the reductive strategy, which is what I'll talk about next time. So this is quoting Goodman now in the sort of middle chapter of Fact, Fiction, and Forecast. A philosophical problem is a call to provide an adequate explanation in terms of an acceptable base. If we are ready to tolerate everything as understood, there's nothing left to explain. While if we sourly refuse to take anything, even tentatively, as clear, no explanation can ever be given of anything. What intrigues us as a problem and what will satisfy as a solution will depend on the way we draw the line between what is already clear and what is in need of what is already clear and what needs to be clarified. That should be clarified, not qualified. So in the absence of any convenient and reliable criterion of what is clear, the individual philosopher can only search his philosophical conscience. This talk of conscience is simply a figurative way of disclaiming any idea of justifying these basic judgments. But this seems to me to give up too soon on the explanation of why something is problematic. Even if a general criterion of drawing this line might, one might expect some, even without a general criterion of drawing this line, one might expect some account of what it is about a particular concept that makes it philosophically problematic. But one of the virtues of reductive analysis, if you give a reductive analysis, I don't know if it's really a virtue, but if you give a reductive analysis, you don't have to explain why your problematic concept was problematic. It's not problematic anymore, so long as the things you reduce it to aren't problematic, because that's all that's left when you give a reductive analysis. So reductive analysis is a way of solving problems without saying what the problems are, without the need to say what the problems are. But we can say more. You have to say more if you're going to solve it in some other way, and we can say more about the empiricist tradition. And you find is skeptical about objective modal concepts, natural necessity and possibility, in contrast both with subjective modal concepts, which are explained in terms of, in terms of belief and sort of attitudes, subjective attitudes, on the one hand, and semantic modality, on the other. Modal concepts are to be explained in to use Hume's language, in terms of relations of ideas, not matters of fact. They're not in the world, they're in the mind. Semantic connections. So one can, the idea of the skepticism that lies behind the empiricist project is rooted in the judgment that necessary connections in nature are not observable. One can observe what happens, but not what has to happen in any sense of must. What must happen in any sense of must. One can observe regularities in nature, but not connections between facts. The empiricist project, then, is to explain empirical modality by reducing it or factoring it into logical and semantic modality on the one hand, and modal matters of fact on the other. So next time, I'm going to start by looking at the specific project of reductive analysis developed by Nelson Goodman in the 40s, and why it failed on his own terms, why he regarded it as a failure. But Lewis came along and said, we can do better. We can accept the demanding requirements of reductive analysis, but with richer tools, we can still succeed in reducing natural necessity to mere matter of fact. So I think that's a misconceived project, and that's what I'll argue for next time. So, thanks. Okay, today my focus is going to be on counterfactual conditionals and the project of analyzing them by giving a kind of metaphysical reduction. And my general line that I'm going to try to defend is that this is a mistake. It's not possible to give a reductive analysis, and furthermore, a reductive analysis is not well motivated. But in doing that, I want to sort of bring out exactly what are the commitments of a reductive analysis. And there are different kinds and different motivations that one might have, and I'm going to argue that the traditional motivation, the traditional empiricist motivation for some kind of reductive explanation of not only of counterfactuals, but of the family of concepts involving natural necessity, that the traditional empiricist motivation for this project is radically different from Lewis's motivation, but he adopts some of the same sort of ways of thinking about it. Okay, so my plan is, first I'm going to start by looking back to a version from the late logical empiricist era by Nelson Goodman, the classic paper by Nelson Goodman, and at exactly how he understands the project of giving a reductive analysis of counterfactuals and why he regarded it as a failure. And we'll look next time at what the alternative is if once you regard it as a failure, both what Goodman thought the alternative strategy was and what I think more generally the way we should think about the alternative way of explaining this family of concepts of natural necessity. So I'm going to start by looking at Goodman. Then second, I want to make some general remarks about the strategy of metaphysical analysis. And of course, the traditional empiricists did not think of their analysis as metaphysical, but often later versions of the same kind of theory talk less about reductive definition, as if it were kind of a semantic notion, and more about a notion of supervenience. That is, that all there is in the world is given by some unproblematic description at a certain level, and all the rest is supervenient on that. That is, if you were to fix all of the facts of the unproblematic kind identified, then you will have fixed all the facts, everything that there is a fact of the matter about. So the later sort of version of the kind of reductive strategy is metaphysical in the sense that it's a theory about what there is a fact of the matter about. What are the facts in the world that we, or the facts about the world that distinguish between real possibilities. Okay, so that's the second thing, is general remarks about them, including other kinds of reductive projects, but the general idea of a metaphysical reduction. Then third, I want to look at Lewis's more specific reductive project and at his concept of Humean supervenience. So Lewis has a view that everything there is a fact of the matter about is reducible to a certain kind of description or characterization of the world, and the project then is to reduce things to that, anything that is apparently of a different kind, to explain how it really isn't of a different kind. So a reductive strategy generally will be kind of hierarchical, and sort of goes with contemporary ways of thinking about metaphysics in a kind of hierarchical way. One makes a lot of deal about fundamentality, and there is a fundamental level of description of the world, and if there are other things, they are somehow more derivative or less fundamental. So, and the explanation or defense of a supervenience thesis of this metaphysical kind may involve a further hierarchy. That, as you say, first we're going to reduce a certain basic notion to some even more basic notion, and then we're going to go and reduce some further thing to the first two, and so on. So in particular, Lewis's project takes a very explicit hierarchical form, an order of analysis specified so that one takes pains to avoid circularity. Okay, so that's the third thing, and the main sort of part of the project, that Lewis project that we'll focus on, is the explanation of one has a semantic analysis, an abstract semantic analysis of counterfactuals in terms of what Lewis thought of as a similarity ordering, comparative similarity ordering between possible worlds. And one can characterize the similarity relation, the structure of it abstractly, but that puts very few constraints on the substantive nature of the explanation, of the nature of the relation. So the question is, how should one explain in terms that are unproblematic from the point of view of the supervenient space what the order of similarity is? And we'll see when we get there. There's a more specific problem that Lewis is concerned about, which we also should be concerned about, concerning the relationship between temporal order and the order of causal and counterfactual dependence. Okay, so we'll look at both the general idea of Lewis's account and at his criteria of similarity that he proposes. And finally, at the end, I want to make some general remarks about the supervenient space, and particularly the contrasting motivations. I'm going to spend some time looking at some traditional empiricist ways of defending the need for Humean reduction to a Humean base, and contrast those with Lewis's very different ways of thinking about it. Okay, so start again, as I say, with Goodman's project. So the general form, this is again the first section of the handout, the general form of the analysis is this: a conditional, and I'll use Lewis's notation, which is a box arrow connective for the counterfactual conditional. A conditional A, box arrow C, or if A then C, if A were the case, then C would be the case, is true if and only if, according to Goodman's general form of the kind of analysis he's looking at, if and only if you conjoin A, the antecedent of the conditional, with a suitable set of true propositions, gamma, and if that set of sentences entails C, then the counterfactual is true. If it fails to entail C, then the counterfactual is false. It's a constraint. So the way Goodman conceived of the project, the problem is to characterize the set gamma. This is not quite the way Goodman puts it, but it's sort of streamlining it into a very abstract form. Now, gamma has got to be a set of true sentences, but if it were the set of all true sentences, it would include not A, because we're assuming we're analyzing counterfactual conditionals where the antecedent is false. So you would get an immediate reduction of your analysis to the material conditional, which, as Goodman and everybody else will agree, is unsuitable, obviously, for counterfactual. So the counterfactual is a proposition in the normal case. Not all subjunctive conditionals have this feature, but the sort of paradigm counterfactuals are conditionals for which it is presupposed that they taken for granted that the antecedent is false. So it would follow from what you're taking for granted, the conditional, no matter what the consequent, if the conditional were material. So it's agreed that counterfactuals, I mean, there's some defense of indicative conditionals analysis as material conditionals, but nobody thinks that counterfactuals are, if you can make sense of them at all, are material conditionals. So the problem is to characterize the set gamma, or which is really index this to the antecedent, because the relevant set of conditions will be relevant to a particular antecedent. Okay, so Goodman assumed that the project of explaining gamma, or gamma sub A, would have a set of conditions which are facts that you can use to derive the consequent, is something that has two parts, a set L of laws of nature, and a set of what he called relevant conditions, which are factual conditions, particular matters of particular detail, which are suitable to assume in assessing a counterfactual. So the problem is to characterize those two things. Now, the problem of the problem of laws of nature was a familiar problem in the positivist tradition of trying to explain theoretical language in terms of the observation language. The problem is recognized and thought of in these terms. It was to say, look, if we had counterfactuals, we could explain the difference between laws of nature and mere accidental generalizations. So we use an example, somebody used all the dimes, all the coins in my pocket are dimes, is an accidental generalization. Nobody thinks that this is some deep truth about my pocket or dimes, all the people sitting on that bench speak Swedish. This might be true, and it's a universal generalization because it's everybody sitting on that bench. Obviously not a law. So what's the difference between laws and accidental generalizations? Laws, one of the ways of trying to explain it would say laws support counterfactuals. Even if all the coins in my pockets are dimes, if I put some euros in there as well, then it would no longer be true. So if there were euros in my pocket, it would be false that all the coins are. So that generalization doesn't survive counterfactual judgments. Whereas a law of nature is supposed to be one that's not only true, but would be true under various counterfactual, would remain true under various counterfactual conditions. But then we say, but we want to use laws to analyze counterfactuals, so there's the danger of circularity. So the people in the Goodman tradition and the positivist tradition generally insisted that we need to give some explanation of laws of nature. So that was part of the problem, to say what is a law of nature? It's a universal generalization, but not just any old universal generalization. The second part of the problem is what, as I say, what Goodman called the problem of relevant conditions. So I use sort of standard kinds of examples that Goodman used. The coin, or rather the match wasn't struck and it didn't light. Would it have lit if it had struck? You say, well, it's a fact that it didn't light. That's a fact that you can't obviously continue to assume as being something that would still be true even if the match were struck. There was sufficient oxygen in the room, as a matter of fact, and we can assume that if the match had been struck, there still would have been oxygen enough. The match was not put in water before it was struck. We can assume that in the world, as it would be if the match were struck, it still would be true that it wasn't put in water. Why do you assume these things can be maintained, these can't? So Goodman's project was to try to explain by using certain very specifically limited resources what the rules were for ruling in and ruling out various facts, particular facts, as well as laws of nature. So one can see this as a single problem, the problem of specifying the whole set gamma, including the laws and the relevant conditions. What are the constraints? And again, the constraints are governed by the motivation for finding an analysis. They're empiricist constraints. So we're allowed to rule in and out various properties in virtue of their truth value. That's given, that's to start with. They got to be true. But second, we can use logical relations between the antecedent, the consequent, or any combination of the antecedent and the consequent, and the candidate. So VS is some fact S, some true sentence, because it's all thinking this in very linguistic terms, some true sentence S allowable into the set of relevant conditions. Well, we can say whether it entails or is entailed by A, whether it is entailed or entailed by C, whether it's entailed by some disjunction or construction out of these things or whatever, but we can't appeal to anything else. In particular, Goodman was very clear that it was not legitimate to appeal to syntactic properties, such as whether a sentence is disjunctive, for example, whether a condition is, a sentence stating a condition is disjunctive. That's a syntactic property of a sentence. But Goodman emphasized, and this is part of the whole Grubline story, that syntactic properties were ways of characterizing a certain particular way of expressing some I mean, we would say from proposition, but Goodman didn't believe in propositions. But you want to explain things in terms of the extension, because again, you want to talk about meaning, but you want to explain things in terms of the extension of the predicates that were relevant, the conditions that were relevant conditions. So if you could formulate a disjunctive sentence in a different way by having a primitive one that meant what the disjunction meant, and so that would be the same condition, really. So he ruled out the legitimacy, as did other people giving analyses of explanation and other notions in this time, ruled out the legitimacy of syntactic properties. Okay, so what's left? And Goodman tried various things. He said, well, you've got to insist that the condition can't be entailed by the consequent or by the falsity of the consequent, or by itself it can't entail the consequent. Together with the antecedent it can entail the consequent. That's what we want. But it can't entail the consequent all by itself, you might say, or it can't entail the negation of the consequent by itself. And it can't entail the antecedent, maybe it can't entail the negation of the antecedent, and so on. And he tried out various combinations, and he also considered the possibility that maybe you should put a negative condition in. So you've got to find a set of relevant conditions that satisfy some properties, but there's no set of relevant condition that yields the opposite conclusion. So you might have a condition that enforces that you're never going to get if A then C, and also if A then not C. So he tried on various things and eventually said nothing's going to work. And his sort of rhetorical device for giving up at the end, it isn't that he proved that nothing could work of the kind that met his conditions, but he simply said, well, what we really need is a condition which he called cotenability. So what is cotenability? That is, a condition has to be cotenable with the antecedent, which means it's a fact, it's something true, but it's not that it would be false if the antecedent were true. So one of the reasons you can't include the match didn't light among the relevant conditions is that that's something that wouldn't be false anymore if the match were struck. But Goodman says, but cotenability is explained in terms of counterfactuals. So our analysis would be circular if we allowed an appeal to cotenability in giving the analysis. Okay, so as I mentioned last time, rather than giving up and taking it to be a sign of failure, that the most natural explanation of the line between relevant conditions and things that were not relevant or not allowed, or not admissible in this set, rather than give up when the analysis became circular, he might have thought, well, let's take our theory not as a reduction, but as a pair of axioms, which don't uniquely determine a value, but do constrain the interpretation. So we have the proposed analysis, which was that if A then C is true if and only if A conjoined with gamma sub A entails C. Okay, and then you say, so our problem is what's gamma A? And we give our circular account of gamma A by saying S is a member of gamma A. Any given sentence is a member if and only if it's not the case that if A then not S. And you say, given this definition, this is not a reductive analysis. But still, if you say, here are two postulates governing the counterfactual, and one can ask, what are the properties that this pair of axioms enforces on the counterfactual? And you can say quite a lot on this basis. In particular, one can say that the counterfactual obeys certain logical principles, such as if A then B, and if A then C, then if A then the conjunction of B and C, and so forth. So, so this would have been a start on a different project, but Goodman was interested only in a reductive analysis. Now, when we get to Lewis, Lewis was interested in getting clear about the logical structure of the counterfactual, and that played a role in setting up the problem which corresponded to Goodman's problem of explaining relevant conditions. So once you set it up and give a formal semantics for the counterfactual, simply taking for granted, in a way in which Goodman was not willing to, taking for granted problematic notions and saying we take them for granted and then we have the project of explaining them. But we've sharpened or clarified or changed, in a way, the problem of explaining from a sort of more linguistic problem of specifying a set of sentences to a problem of characterizing a sort of overall parameter of the relation of the semantics, which in Lewis's term was a comparative similarity relation. Okay, so that's Goodman's project, and as I said in one of the papers that some of you read, just as a sort of interesting sociological note, Goodman was one of David Lewis's teachers at Harvard, and so was Quine. And Lewis took it upon himself as his early work to try to refute his teachers. So in particular, his teachers were arguing for negative conclusions. In particular with Quine, there's no such thing as truth by convention, and there's general rejection of the analytic-synthetic distinction. And Lewis's first project was an analysis of convention, an analysis which did not have the properties that Quine was worried about, and which did, Lewis argued, permit a coherent notion of truth by convention. And Lewis's work is very important on convention. It led to that, to a range of further work and application, both within philosophy and in computer science and other places. Lewis's second project was the analysis of counterfactuals, arguing that Goodman was wrong. You can give a reductive analysis of counterfactuals, not in Goodman's framework, but in a radically different framework, one that Goodman, just as Quine rejected the kind of whole possible worlds way of thinking that Lewis used, all the more so would have Goodman. Okay, so we'll come back to Lewis's version of this, very different version of this project. But first I want to say, as I said, some general things about metaphysical reduction. And in particular by looking at a number of different cases of this kind of reduction. So as I say here, viewed in the handout, start of section 2, viewed abstractly, a project of metaphysical reduction is the defense of a thesis that says that a complete description of the world can be given in terms of resources of some specified kind. So, for example, to get some more traditional empiricist reductive projects, the original Carnapian and other early logical positivist project was an attempt, took the observation language to which all of science should be reduced to be a phenomenalist language, a language where the basic concepts were phenomenal concepts of phenomenal experience. So color concepts, for example, where by color you mean a property of an experience. Different ways of spelling out what a phenomenal object is, sense data, and different ways of saying what sense data are. But the original idea was to try to reduce objective language to phenomenalist language. One of Goodman's teachers, another Lewis, C.I. Lewis, was a phenomenalist, and Goodman took after him in this regard. And some of the problems about counterfactuals first come up in the attempt to explain physical object properties in terms of phenomenal properties. So C.I. Lewis talked about a whole infinite range of counterfactual judgments of the form, if you did this, you would have an experience of this. If you did that, you would have an experience of that. So to explain what it means for, say, a piece of paper to be white would be partly to explain if you did certain things with the piece of paper or looked at it in certain ways or so on, then you would have experiences of this kind and that. Enormously implausible, everyone thinks later, but that there's any hope. It's such a tremendously ambitious idea to try to take. The world itself just consists of phenomenal experience, and our whole theory of an objective world comes from counterfactual thoughts about how our experience would change as we move around in the world. The problem of counterfactuals as it sort of becomes particularly salient to Goodman, partly through his phenomenalist, the project of using counterfactuals in an application of a phenomenalist theory. And of course, along with fact, fiction, and forecast, Goodman's most famous work, The Structure of Appearance, is an attempt to do the kind of thing that Carnap did in the Aufbau, the logical structure of the world, and do it with more sophisticated logical resources. But it was like Carnap's early project, a phenomenalist project. So phenomenalism is a particularly severe and implausible or an ambitious version of a metaphysical reduction. More generally, when the positivists became more moved from a phenomenalist language to what they call the physical thing language, there's a thought that we have an observation language, which is a language for describing the objective world, but describing the objective world in terms of observable properties of observable things in the world. So that's your base. You say all the world in a sort of early, most hardline, but not phenomenalist, the sort of next step down was to think that what there is in the world to talk about is just what can be stated in the observation language. And to the extent we can make sense of higher order theory, which involves unobservable properties and unobservable objects, that has to be reduced to the observation language. Later on, one gets different views about the relationship, more loose views about the relationship between these different languages. But at least it is an example of a reductionist project in the positivist tradition. Now, moving outside of the positivist tradition to later, more overtly metaphysical theses, materialism or physicalism is a project of metaphysical reduction. It says that physics is the fundamental theory of the world, and everything there is in the world can be explained or described in terms of physics. To the extent that we have concepts that seem problematic from the point of view of physics, they can be reduced to physics. They can be explained as supervenient on physical properties. In particular, the whole sort of materialist tradition in the philosophy of mind is a tradition of trying to not perhaps, the most ambitious idea would try to define mental concepts in terms of physical concepts or functional concepts, which are realized in physical ways. So functionalism and physicalism are versions of a kind of reductive, metaphysical reduction strategy. A different kind of theory, but one that fits the same general pattern, is a strategy of addressing the problems of personal identity. So one can say that all facts about the relationships between continuate objects over time is reducible to or explainable in terms of the instantaneous properties of things at particular times. So someone like Derek Parfit, but also some other people who actually want to talk literally about identity, would say that we can give criteria of identity for continuate persons and also for continuate physical objects, what it is to be the same thing. But what it is to be the same thing is reducible to in some sense, or supervenient on, the instantaneous properties of individual things. Kripke, in unpublished work, has lectures explicitly addressing the very abstract issue of reduction to instantaneous states, arguing against this kind of reductive project. Now, you could be a kind of reduction. Reduction suggests you're actually going to try to define or explain terms that prima facie are not part of your supervenient space. But one could be an eliminativist about the problematic notions in any one of these projects. So one could be a kind of idealist who says there just is no objective world. And we'll see there's some things Ayer says, A.J. Ayer says, that suggests he is that kind of eliminativist. But they're familiar eliminativists about the mind, that is, people like Churchland and early stage Rorty, arguing that the theory of the mind and the soul and so on is all a false theory, a false ideology, a false metaphysics, and then we should just stop talking about thoughts and feelings and talk more directly about brain states, which are all there really is in this realm. So one version of a kind of reductionist is an eliminativist. Another is more ecumenical, trying to explain how talk of the mind or talk of identity over time or talk of the real scientific entities and so on is all legitimate, but legitimate because it's reducible. Or one can give definitions or at least explanations of what we're doing when we talk about these other things. Quine, who is definitely a eliminativist about meaning and about certain mentalistic intentional notions, sort of made the point that in some ways he's like an anti-reductionist. So he said Brentano argued that intentional notions, mental intentional notions, are irreducible. They're for the further level of reality because they're not reducible to the physical, and argued that they're not. And Quine said, well, he agrees with this. They aren't reducible, and therefore they should be eliminated. So the same metaphysical view as the materialist reductionist, but a different idea of what to do with the apparently problematic notions. Okay, so one example of, or perhaps more than one example of this kind of metaphysical reductive project is to take the notions of natural necessity, a whole family of concepts, including objective chance, causal dependence and independence, causation itself, and so on. All of this family of notions should be, including just sort of natural necessity itself, should be need to be explained in terms of a base. But the main thing I want to make, so general point I want to make about the character of a metaphysical reduction is that often the focus is on whether you can succeed, that is, whether a certain explanation of mental concepts in terms of physical concepts, or concepts of continuate objects in terms of instantaneous properties, whether these explanations work, or whether we have to say the problematic notions are really something over and above the base. But those debates presuppose that we have identified a clear distinction between the base and the other stuff. So in terms of sort of language of talking about supervenience, one often talks about the reduction of properties in the A set to properties in the B set. And the problem is to characterize the B set, the set of the supervenience base, and to say everything is reducible or explainable or supervenient on that. But often, while that's taken for granted, often the real problem with the reduction or a metaphysical reductive project is that no base has been made clear. That is, I mean, on one hand you have to motivate taking the base to be something unproblematic, but one also has to explain what it is. And while I think a materialist might be on fairly solid ground here, as a materialist might reasonably say, we have a theory, physics, which is an articulation of a certain kind of property. We say, well, we don't know, we've got the complete physics, so maybe, as Lewis mentions in talking about reduction, maybe the basic or fundamental properties of nature will include some we don't know about yet. But nevertheless, we have sort of a pretty clear idea of what counts as a physical property. And we know intentionality, meaning, aboutness, these kinds of things aren't, or experiential properties like feeling painful or something like that. These are not something that physics talks about or will talk about even in a fundamental physics. If the fundamental theory of nature winds up talking about aboutness or painfulness, then that will show materialism is false. So we have some pretty clear idea what the base is in that case. For many other reductive projects, it's much less clear that whether they have identified a base. Many people argue against, say, the kind of reduction to instantaneous properties by arguing that the very concept of an instantaneous property is not intelligible, except in terms of its relationship to properties that exist across time. And one of the ways to make this point is to focus on a notion like instantaneous velocity. So does it make sense to think of instantaneous velocity as a property of an instant that's separable from the surrounding, what's going on in the surrounding times? So could you take a time slice where something is moving with an instantaneous velocity of 100 kilometers an hour and embed it in a different place where it's also at the very same place before that and after it. So the instantaneous velocity is not identifiable in that other context, but it's still sort of there underneath. Or say, no, that doesn't make any sense. So instantaneous velocity is not really an instantaneous property. So one would say, well, there are real instantaneous properties, and everything is supervenient on them, including only apparently ones which are abstractions from continuous properties. But that is part of a project not only of defending the reduction to a base once you've got the base, but of saying what the base is. So I want to suggest that the central problem with Lewis's project of metaphysical reduction of the natural necessity concepts to a base is that the base itself has not been coherently identified. Okay, so let's look more specifically then at Lewis's project of reduction, and we have some. I mean, one of the things they say, I think, well, I don't think Lewis's project works. Part of the work of showing that it doesn't work is helped by the extreme explicitness and clarity of Lewis's characterization of his project. So I think, while I think the project doesn't work, it is spelled out in a way that helps us to see what's wrong with it. Okay, so I'll start with two, on the handout, two quotations which are attempts to characterize the base. And again, that's our main focus here, is what is the base, what is the supervenience base? What are we trying to reduce concepts of natural necessity to? And this is a helpful thing for trying to distinguish what's distinctive about natural necessity as contrasted with something else. Okay, so I'll read both of these, but and this is from an introduction to his philosophical second collection of philosophical papers, which is mainly about the issues concerning natural necessity, all the papers in that collection. Humean supervenience is named in honor of the great denier of necessary connections. It is the doctrine that all there is in the world is a vast mosaic of local matters of particular fact, just one little thing after another. We have a geometry that is in our characterization of the world. So again, this is sort of a general theory. What is characterization of the fundamental nature of reality. What form does it take? And he's very explicit about this. We have a geometry that is a system of external relations of spatiotemporal distance between points. Okay, now, this is a relational structure. And that's one of the things that's given in the characterization of reality. And then he says, again, this is put in a tentative way, but it's defining the thesis that he wants to defend. Maybe the points of space-time itself maybe point-size bits of matter or ether or field, maybe both, are also things in the world. So in the world we have a space-time structure, and we have space-time points. In that structure we have point-size, perhaps we have point-size bits of matter, or perhaps we have point-size properties of fields or of the ether. And again, he's trying to be neutral about what the correct physics is going to turn out to be. Maybe we have fields, but fields are all identifiable by properties of instantaneous, of particular momentary points in space-time. And at those points, we have local qualities, perfectly natural intrinsic properties, which need nothing bigger than a point at which to be instantiated. For short, we have an arrangement of qualities, and that's all. That's reality. There is no difference without a difference in the arrangement of qualities. That's the supervenience claim. No difference in anything else without a difference of this. All else supervenes on that. So that's the sort of rough, intuitive characterization of Humean supervenience. And they say, well, I think this is extremely clear in a way when we start looking at what these qualities of point-size things are. It becomes much less clear what we're talking about. Okay, second quotation, this one from The Plurality of Worlds, written a little bit later. The world has its laws of nature, its chances and causal relationships, and yet perhaps all there is to the world is its point-by-point distribution of local qualitative character. We have a spatio-temporal arrangement of points. At each, various local intrinsic properties may be present, instantiated perhaps by the point itself, or perhaps by point-sized bits of matter or fields that are located there. Okay, just repeating the same basic idea in slightly different words. And then, but going on, there may be properties of mass, charge, quark color, and flavor, field strength, and so on, and the like. And there may be others beside, if physics as we know it is inadequate to its descriptive task. Is that all? Are there laws, chances, and causal relationships? That is, or are laws, chances, and causal relationships nothing but patterns of which supervene on this point-by-point distribution of properties? Question mark, but that's the thesis. Okay, so again, the main thing I want to do is contrast this conception of the base with what the empiricist was thinking, which is what motivated Hume in finding natural necessity problematic. So again, quoting Hume, upon the whole, there appears not throughout all of nature any one instance of connection which is conceivable to us. All events entirely loose and separate. One event follows another but we never can observe any tie between them. They seem conjoined in space and time, but never connected. Okay, that's from the inquiry, is again characterizing the way Hume's thinking of his motivation for this denial of necessary connection. It's because it's unobservable. Though there is no, and again, a specific remark about the notion of chance, which is one of the notions in the family of natural necessity concepts. Though there is no such thing as chance in the world, our ignorance of the real cause of any event has the same influence on the understanding and begets like species of belief, or like it begets like species, a like species of beliefs and opinion, again from the inquiry. And then one of the peculiar features of that particular quotation is while he's denying chance, he's appealing to cause. One of the causes of our, and then we talk about influence, and the event has the same influence on the understanding as a chance event would. So we have a kind of, as people have remarked and criticized Hume for his inconsistency in having a causal explanation for the fact that there is no such thing as causal connection. Okay, now following in the same empiricist tradition with the same kind of motivation, we have again a whole page of quotations from a rather unfamiliar paper of A.J. Ayer about conditionals, in particular about counterfactuals. And one of the things Ayer makes clear is this is kind of the phenomenalist character. As in Hume, all what's problematic about necessary connection, it's not an idea that can be explained in terms of impressions, sense impressions, phenomenal properties of experience. And Ayer has the same kind of view. I propose to look upon the world as consisting of a bedrock of fact, and the only statements which I shall regard as being strictly factual will be those that are limited in their content to supplying true and false descriptions of this world, together with such statements as are obtainable from them by quantification of the use of extensional operators. All other empirical statements, or at least all those that function at a higher level, will be construed as relating to the arrangement or the explanation of what is to be in the primary facts. Again, it's trying to characterize the supervenience base as a level of bedrock fact, one little thing after another, as Lewis put it. But he emphasizes that he said, I'm making a distinction which ordinary language blurs. Thus, familiar objects is recognizing that our familiar common sense way of talking about the bedrock of fact, factual things in the world, even at the observation level, involve concepts that are causally loaded, something that many people have emphasized in criticizing Hume. So my examples are meant to be identified by their phenomenal properties. My reference to them is not to be understood as carrying any logical implication about their powers. And Lewis must say the same thing about his properties. Powers are, or capacities, or dispositions, are features of the world that are part of the problematic character that need to be reduced to the more basic level. At one point, Ayer considers the question a little puzzle about what we should say about a counterfactual flip of the coin. So if this is the case, if we had a clear counterfactual, how would the coin have landed if it had been flipped? It's a fair coin. How would it have landed? He concludes that the statement, if I had flipped that coin, it would have landed heads, is not meaningless. We can make sense of it, but it does not have a truth, it lacks a truth value. But then he raises a puzzle about this. He said, we're in our ordinary talk, we allow the principle of excluded middle, allow for truth values, applied to statements that are that there are flowers growing in some unexplored cranny of a mountain, not unexplored but never to be explored, shoals of fish swimming in a sea, even though their presence goes forever undetected. In these cases, we can indeed claim that the statements are testable in principle, but still they're not phenomenal statements. They're tested in terms of phenomenal statements. But the phenomenal statements that test them are themselves counterfactual. A suitably equipped observer might have occupied the required spatiotemporal position. But then he says, but then, of course, I might have tossed the coin. So you can think of the possible toss of a coin as an empirical test. So can we say that if we had tossed the coin, it would have landed heads or it would have landed tails? And that's a test of how the truth value for that counterfactual. What's the difference? And he tries to explain the difference, but not in a very not in an obviously satisfactory way. Just some sort of general remarks that he makes. It's only at some level of theory that we can form any picture of an objective world. Okay, so the theory about the objective world is not part of the base in the way he's thinking of it. And again, a final remark, which is most striking example showing, of a remark showing that Ayer is kind of an expressivist, an anti-realist about the objective world. Right? The upshot of this discussion is that, in a certain sense, causes are what we choose them to be. We do not decide what facts habitually go together, but we do decide what combinations are to be imaginatively projected. The despised, to say something politically incorrect, the despised savages who beat gongs at solar eclipses to summon back the sun are not making a factual mistake. They see what is going on as well as we do, if you're talking about the objective reality. It's just that they have a different, and we think, we have a different and we think better idea of the way the world works. But the very idea that this better idea about the way the world works is not something that's true or false, but rather just a matter of imposing our imaginative ideas on the objective world. So if you follow the true Humean motivation into the modern time, as Ayer does, you get an extremely implausible view of what the supervenience base is. It's a phenomenalist base. But Lewis does not follow this, idea. Rather, as we saw in the characterization of Lewis's notion of Humean supervenience, the properties that we can take to be part of the base are the properties of point-sized bits of matter or fields or things located in fields or in space. And he said these are properties like mass, charge, quark, color, and flavor. Field strength, and so on. Just the properties that Ayer said were not part of the base because they're causally loaded. But for Lewis, these properties, these fundamental properties of physics, are not causally loaded. So Lewis' metaphysical theory explicitly separates the property itself from the laws of nature that state contingent laws of nature, which state the relationships between properties and the way in which properties evolve over time, and the way in which the world evolves over time. So One might think that it's intrinsic to the very idea, say, of electrical charge, that negative charged particles repel each other. But that's a law that happens, and it's a wholly contingent law. So Lewis would say, in another possible world, particles which are negatively charged attract one another. Or maybe they just are neutral with each other, or whatever. So the difference between positive charge and negative charge, between mass and energy and all these different things, all these are contingent properties of intrinsic properties which have no causal structure to them, or no causal properties. So the very idea that there are such properties is itself a highly problematic notion. So my general view is that we have a coherent Humean project, but one that's extremely implausible because I mean, you can understand how phenomenal properties, that is just the mere experience of a red color or of warmth or something like that, has no intrinsic causal properties. It's just there and identifiable in itself. I don't think that's itself a plausible idea, but it's at least one can understand why one's leaching out the causal properties when one goes from physical object properties to phenomenal properties. But the idea that one can do the same thing with the fundamental properties of nature, and so there's nothing empirical, nothing to do with how we know about these things, that is our reason for taking them to be unproblematic. So why should we take these pure intrinsic properties which are part of the nature but have no causal powers that are intrinsic to them? Why should we take these to be unproblematic? Okay, well, I'm running out of time again too early, but let me just say a little bit about the order of explanation in Lewis's project. So first thing we have to do, and this is what Goodman would have said too, but he didn't really have much of a theory of this. We need to explain laws of nature. That's the thing that comes first. We're worried here about avoiding circularity, so we're going to say we're going to appeal to laws of nature, which is a problematic notion, but first we're going to explain them, independently of causation, independently of counterfactual dependence, and so on. So laws of nature are to be thought of as simply patterns, global patterns exhibited by the world as a whole. So he has what he calls a best systems analysis of laws. Again, there's a lot of the details aren't worked out by Lewis of these things, but a very clear idea of the order of explanation. So there's plenty of problems with explaining what the best system of laws is, but it's all to be supervenient on the pattern of distribution of particular facts. And so one wants to sort of have an economical formulation of the basic principles that govern the patterns, and those are laws of nature. Second in order is the explanation of comparative similarity in terms of laws plus distribution of particular facts in time. So counterfactuals come pretty early in this stage of a general reduction of counterfactuals to laws of nature plus particular facts. Then third, in terms of counterfactuals, we can define a notion of counterfactual dependence and independence. And again, it's fairly straightforward, this step, worked out in clear enough detail. Fourth, causation is to be explained in terms of counterfactual dependence. It's not to be identified with causal dependence because there are all kinds of problems of detail in explaining causation, which he addresses over a whole series of papers. But as Lewis emphasizes, each step in the process has its own set of problems, and this is only a general strategy and not a finished reductive project, but it's clear what counts as success in this project, so long as one's clear about what the base is. Okay, then we'll talk more when we look to the alternatives to reduction at the specific priorities that he had. But you can look at that and see to see exactly how he's going to try to explain what the relevant comparative similarity relation is. He emphasizes that the ordinary impressionistic notion of similarity between possible worlds is not the relevant notion. Okay, so finally, just a remark about the supervenient space. Again, I've said this, but for Hume and for Ayer, the Humean reduction is a phenomenalist one. Impressions are the source of all ideas. For Lewis, the base consists of the fundamental properties as identified by physics. But the question is it plausible to think of these properties as separable from their causal powers? Lewis is quite explicit that on his metaphysical picture, the fundamental properties are only contingently connected to their dispositional features and to the laws of nature. If one judges, as I do, based on this sort of schizophrenic motivation, really, for the attempt to find a reductive analysis, that the inductive project is misconceived, what's the alternative? What kind of explanation, short of reduction, should we give of the priorities that govern the selection of the relevant possibilities for the interpretation of counterfactual conditionals? So I want to agree with Lewis that what we need is some kind of explanation for the nature of this so-called similarity relation. But we don't have a reductive explanation, but we also don't want to say, oh, it's primitive, just take it, right? Use it. We want to say something about what function it's playing, and that will help us see how we make it. And the explanation I want to give does tie closely the criteria of similarity to the epistemic uses of counterfactuals, which connect with the epistemic uses of indicative conditionals. So we'll look back again a little bit at the indicative case and see how what role that plays in trying to characterize the respective similarity which we use to interpret counterfactuals. Okay, thanks. So, so far, particularly last time, my arguments, such as they are, have been mainly negative. Although I tried to articulate a certain approach to a strategy for solving problems about counterfactual conditionals, I argued it was a misconceived strategy. And the main focus of my argument was not that it doesn't succeed on its own terms, but that it makes the sort of metaphysical assumptions about the nature of the fundamental base to which one reduces counterfactuals were implausible. Today I want to focus mainly on a positive alternative, because if you in general reject a reductive strategy, it's not, and yet you still say there's something to be explained, there's some problems that need to be addressed, one has work to do to explain what those problems are and to say what alternative short of reduction counts as progress on understanding the concepts. But before we get to that, I want to make, I didn't get time to go into very much detail about Lewis's constructive project, that is what he's doing with the metaphysical assumptions that he's making. I did spell out on the handout a sort of sequence of steps, and a crucial requirement of his project is that the steps be non-circular. That is, when one explains the first of the problematic concepts in a way that makes no assumptions about any others, and once one has explained that, then one has it to use to make further steps in explaining other concepts. So, talked a little bit about laws of nature, which on Lewis's view are just completely descriptive generalizations about regularities, patterns of regularity in the distribution of particular facts. They, in the sort of intuitive understanding of explanation, one might say, they don't really provide an explanation for anything, for the way the facts are. It's not that we don't explain the uniformities by the laws, that is, the patterns exist because of the laws, but rather the laws simply are descriptive of the patterns. Each step, Lewis would agree, of his argument, of his analysis of the whole family of concepts has its own problems, and each one is an unfinished project with more work to be done. So it's only presented in a kind of tentative way. But I wanted to just make a few remarks about why a more critical kind about the project from its own terms, in that the particular task of explaining the criteria of similarity that govern the interpretation of counterfactual conditionals don't do what he thought they would do. That is, they don't work on their own terms. To explain at least one feature of counterfactuals, which is in need of explanation on anybody's account. So, again, it's important for Lewis that these criteria be spelled out in a way that's neutral, which makes no assumptions about causal structure. Otherwise, I mean, it's not circular. We do have, however, the notion of a law of nature to work with, because that's something which explains prior to the... Goodman assumed in his analysis that the laws remain fixed in the counterfactual. I mean, they were part of the factual things that could be held fixed and used to derive the consequent of the conditional. Lewis, and this is one of the surprising discoveries of his work, says, at least on the assumption of determinism, you cannot keep the laws fixed. So his criteria don't say, first priority, keep the laws intact, because, well, we'll see. We'll talk more later about the problems with conflicts with determinism. But instead, the most important thing is to keep the little facts exactly the same over as large a stretch as possible. So a world in which is precisely the same descriptively or over a range of time is a closer world than one that's diverge, all other things being equal, which diverges more often or sooner or later or whatever. So hold the particular facts fixed for a long period of time. Second requirement was don't violate the laws in any big way. No major or multiple miracles. Going to think of a miracle just as a technical term for a violation of the law of nature. A violation of our laws of nature, of course, is not a violation of the laws of nature in the counterfactual world. The counterfactual world will have other laws. But the laws have to be close, in a sense. This is another distinction that needs to be explained, the distinction between major and minor miracles. So Lewis's thought was, if you hold, you have to, if the antecedent is false, you have to introduce some violation of the law of nature to make it true. But we make a little one, keeping the actual course of events up to close to the time, if the antecedent is a sort of about an event, which is the thing he focuses most on, then you want to hold the world absolutely fixed up until a certain time very close to the event when the antecedent takes place. Then introduce a little blip, a little miracle, which sort of shifts things and makes the antecedent true. But and then he suggests in doing so, having held the rest of the world fixed, the little miracle will proliferate and will lead to great, radical, big changes in the subsequent course of events. And that's unavoidable, he suggested. So either you have to change the facts, the particular facts all along, or else you have to introduce a very big miracle if you're going to keep things approximately the same later. So one of the things that needs to be explained with counterfactuals is why is it that in our ordinary intuitive notion, when you say that something might have, and this is Kit Fine's example from a review of Lewis's book, if Nixon had pushed the button starting off a nuclear war, the world would have been very, very different from the way it has developed in the meantime, and everybody knows that, and that doesn't make the counterfactual questionable. So Lewis would say, well, if you can hold the future, whereas the past completely fixed, have a small miracle, and that's the closest world. To which one can reply, well, why not hold the future fixed? Absolutely the same. And let the past be divergent. And Lewis said, well, that won't work. We don't build it into our theory. So it was important for Lewis the theory be temporally neutral. We're not going to make temporal temporal criteria in our. And the reason was he wanted to say it's a fact about the world that causation has the asymmetries that it has. We want to explain the temporal asymmetries of causation. We don't just want to stipulate. Some people, in looking at Humean analyses, have said, well, causes are simply regularities, but the one that comes first is called the cause, and the one that comes later, if there's a constant conjunction, is called the effect. And that's just to stipulate that causation is forward in time. And Lewis wanted to explain it as a de facto regularity, something that derives from the features of the natural world. But given the symmetry in the fundamental laws of nature according to a deterministic theory, if you're a determinist, then one could argue that it takes no more of a miracle to a convergence miracle rather than a divergence miracle. A miracle which introduces a small change in the law of nature which keeps everything the same from now on, but leads to radical variations in the past. And in fact, in response, in criticism of Lewis, Adam Elga has a paper arguing that given thermodynamics, the change in the world to create convergence so that the microstates of the world are exactly the same from now on is just as easy, just a same kind of violation of law as the one that keeps the past the same and changes the future. You can't do both without bigger miracles maybe, but you could do either one symmetrically. So the idea is that it's at least argued that Lewis is sort of implicitly bringing in some sort of causal intuitions into the assumption that there's an asymmetry which is explained by his way of making these distinctions. Now, it's not that I have, on my strategy of how to deal with these problems, a better explanation of the nature of the asymmetries in causal structure. It's a feature that's there, and it is a problem to explain the relationship between stipulation or something that's part of your theory, your conceptual structure, which imposes this regularity, and the extent to which it's in the facts about nature. But at least we'll look a little more at that, particularly when we get to action, where asymmetries are particularly important. Okay, so that's just to suggest that it's not so clear that Lewis's strategy works to even solve the problems that he himself was most interested in solving. But today, again, I want to focus more on the alternative strategy. But I'm going to start with the example we looked at it came up more in discussion, but the famous example of Alan Gibbard's of the Mississippi riverboat. So we talked about this, so I'm not going to go into detail, but on the handout it sort of spells out in detail. And there's a very artfully designed example to try to make it very difficult to explain on a truth conditional propositional account how the context could be different in these two cases. And I don't want to sort of re-argue that issue so much as to go on and make some further points about what this example shows. Okay, so basically the form of the example, it's an example where one person is in a position to rule out one possibility, but leave two others. A second person is in a position to rule out another of the three possibilities, but not the two others. And it's only by pooling the information that the person who gets both pieces of information can draw the conclusion that it's the third alternative that's the correct one, the one that neither of them is in a position to rule out. Okay, so Pete either called and won in the poker game, he called and lost in the poker game, or he folded, not seeing the bet, not calling by seeing the bet. And one person sees both hands and so knows that Pete has the losing hand, and the person who has the losing hand, if he folds, would lose. So he knows that if he did call, he lost. The other informant knows that Pete is cheating, and he knows, so therefore knows both his own hand and his opponent's hand. And given that he's the presupposition that he's rational, he's not going to call unless he has a winning hand, and so therefore, if he calls, he will win. That's the first person doesn't know whether neither one of them knows whether or not Pete called. Okay, so that's the form of the example. What does it show? I mean, when I say, well, both the informant's statements, conditional statements of the form, if he called, he won, and if he called, he lost, seem to be based on correct information. So it seems, if we say that it's not appropriate to assert something unless you are in a position to believe that it's true, if they do have truth values, it looks like both people, if they're justified in saying what they're saying, then they're correct in saying what they're saying. But the two conditionals seem to conflict with each other. And that was the puzzle, whereas on a truth assertion view, you can explain why they're both justifiable. Now, whatever one concludes about the viability of a propositional analysis of this, of indicative conditionals, the story does bring out, and this is sort of midway through the handout here, the first page of the handout, when the following fact about epistemic dispositions seems to be the take-home lesson, one take-home lesson of this example. So, epistemic dispositions, that is, being in a position to infer something from evidence, is a fragile relationship. Given what else, it depends a lot on what else you happen to know. So one can construct, and this is only one example, it would be easy to construct many examples of this kind of thing, where the same piece of evidence, given one person's background knowledge, would lead one to infer one thing, and the very same piece of evidence would lead a different person with a different background set of beliefs to draw the opposite conclusion. So, again, Quine, Shaw, and even Carnap, I mean, epistemology is holistic. What you're in a position, what the epistemic connections are between evidence and conclusion is dependent on facts of this kind. So this is supposed to be an example of that kind. Now, you can construct lots of examples. Here's one I talked to in the past. Suppose you're playing a game in which you're presented with a bunch of random factual statements in pairs, and you're told that the truth value of the two statements within each pair is the same. So they're either both true or both false. So you might have things like, I say, Milan is further north than Boston, latitude, longitude, whatever it is. So that's one statement. Another, the rainfall in Mexico City, average annual rainfall, is greater than it is in New York City. Nothing to do with each other, these statements. But suppose these, again, I don't even know the answers to these questions, but you have pairs like this, and you're asked to guess whether they're both true or both false. These are cases where if you happen to know one of the facts, you can infer the other from it. So if you had the evidence that Milan was further north than Boston, assuming that it is, if you had that evidence, you would be able to conclude that the other sentence in the pair was true as well. Or if you knew it was false, you'd be able to infer the other one was false. So this is an epistemic connection which is wholly contrived by presenting a person with certain testimonial evidence which gives them reason to make the connection. But no one should look for connections in the world to sort of stand behind the legitimacy of the inference from one of these things to the other. So you cannot move directly from epistemic relations to relations of some kind between facts that the propositions are about. But the observation about the fragility of epistemic and the variability dependent on context of epistemic relevance does not mean that it's not possible to find some more general principles about epistemic relations. That is, to more general statements grounded in facts, which generalizations about when, at least under normal conditions, explain why it's reasonable to make an inference from evidence to conclusion. If there were rules of this kind, rules which tell you if this kind of connection holds in the world, then normally it's from learning that one of these facts, one of these propositions is true, what gives you evidence for the other, then that would give you reason to try to find out those kinds of facts. But the generalizations will have to be defeasible, because given that the very same thing that normally is evidence for not deductive evidence but inductive evidence for a certain conclusion is compatible with it being evidence for the opposite conclusion in other circumstances. But it still might be that one can find some generalizations which will have exceptions when the epistemic situation is more contrived in certain ways than it does. So this is sort of an aim that one can reasonably have. And it's clear enough, before we get to the question of constructive explanation of a general kind, it's clear enough that counterfactuals play a role in stating such generalizations, in making inductive generalizations. So look at further reflections on the Sly Pete riverboat story to see this. So Sly Pete did, as expected, fold. That is, he had the losing hand. He knew he had the losing hand, and so he didn't see the bet, but instead folded. But what would have happened if he had called? That's the counterfactual question. Despite the fact that Zach, the one informant who knew that Pete knew both hands, despite the fact that Zach made no mistake when he said if Pete called, he won, it's clear enough that if Pete had called, he would have lost. Why is this clear enough? Well, this counterfactual helps to explain both why Pete didn't call, since he knew that the counterfactual was true. It was because he knew the counterfactual was true that he chose not to see the bet. And it also explains why Zach, the informant, was in a position to make the indicative conditional claim that he made. That is, Zach could have reasoned, and this is the bottom of the handout on the first page, Zach could have reasoned in this way: Pete, this is Zach speaking now to himself, Pete knows what the cards are in both hands, so therefore he knows whether or not he has a winning hand. Now, if he has a losing hand, then he knows he would lose if he called, and so therefore he won't call unless he has a winning hand. Zach doesn't know that the counterfactual is true, that if he had called, he would have lost, but he knows that if he has a losing hand, he does know that this counterfactual is true, and Pete knows that it's true. So this is an example of the use, on the basis of Zach, of a counterfactual conditional as playing a role in why he's in a position to make the inference, that the inductive inference from his evidence that he made. And Dorothy Edgington emphasizes this in her work, even though she rejects the idea that counterfactuals have truth values. But she wants to say we use counterfactuals in empirical inferences to conclusions about what is actually the case. That is, again, this is the question, what's the role of counterfactuals? Why does what would be true if things that we know aren't true were true? Why is this of any interest if we're interested in what goes on in the real world? And as she emphasizes, and as I want to emphasize, it's they play a central role in epistemic reasoning. Just a few more examples of a kind that Edgington also talks about. First kind of example is counterfactual modus tollens, which Zach's reasoning is one example, although he doesn't fully know but it's conditional reasoning. But if the gardener had done it, there would have been muddy footprints in the garden, but there weren't any, so therefore he must not be the guilty party. So here we use a counterfactual belief. Again, we're not explaining how you know counterfactuals. We're just explaining if you have them, what role they're going to play in inductive reasoning, why it's important, why there's something we want to know. And when then our explanation of how we know them and what they are, what they say, is going to be given partly in terms of what must they say in order to explain the uses that we recognize that they have. Okay, second kind of example, based on a famous example by Alan Anderson, and I'll say a minute about what Anderson wanted to use that example to show. The example is if she had taken arsenic, then she would be showing exactly the symptoms that she is in fact showing. This statement is made in the course of giving an inductive argument for the conclusion that she took arsenic. So we say, in effect, it's sort of hypothetico-deductive reasoning. Here's a hypothesis. She took arsenic. If that hypothesis were true, then the following facts would obtain, and they do obtain. Now, Anderson's point of this example, using this example, was to show that the concept of a subjunctive conditional, the things that are distinctively, must be stated in the distinctive grammatical form that has the woulds and the past tense in it, is not the same as counterfactual. So a counterfactual is somewhat often defined as a conditional proposition where it's presupposed that the antecedent is false. But here, we're arguing for the antecedent, so it's definitely not presupposed that the antecedent is false. But notice that the indicative version of this conditional would be wholly inappropriate and wouldn't do the work that this one does. That is, the indicative version would be, if she took arsenic, then she's showing just the symptoms that she's showing. You can say, well, yeah, if she didn't take arsenic, she's also showing just the symptoms that she's showing. So the indicative is trivial, but the subjunctive is necessary in order to state the kind of fact that you're trying to state, the fact which is the one that plays the role in epistemic reasoning. So one way to think about this example is it's kind of like this. You say, well, we know the symptoms, but let's pretend we didn't. That is, suspend the presupposition that she's showing just the symptoms that she's showing. And then ask your case, say, even under that condition, even under this sort of more robust condition about our particular local epistemic situation, we still would be in a position to infer from the hypothesis that she has arsenic that she's showing just these symptoms. So the idea is, the point of the subjunctive here, or so-called subjunctive, is to say, cancel for the moment the presupposition that we know about the symptoms. and we're still in a position to make the conditional claim. And that's why we put it in the subjunctive, to indicate that we're canceling some presupposition. But if you think, what we're looking for in terms of finding generalizations for helping us understand generalizations about inductive reasoning, then we're looking for assumptions which are robust, which would obtain even in circumstances which were different in the local particular information that we have. So we might want to say, in a wide variety of contexts, with a wide variety of differences in the local information that is available to us, in many of those situations, we would be in a position to infer, if she took arsenic, she will show some symptoms X, Y, Z. So therefore, if we find symptoms X, Y, Z, that's inductive support for the hypothesis. Okay, so what we're looking for is ways of generalizing about the world which give us robust generalizations about how we do inductive inference. So in general, and the reason why this sort of hypothetical deductive reasoning, I mean, in general, to assess the force of evidence received, we consider how likely we would have received that evidence on the various alternative hypotheses. So those are counterfactual suppositions, and they play a very natural and unclear role in the kind of inductive reasoning we engage in. So the general idea of the projection strategy, which is the alternative to reduction that I want to explore, is that we're looking for inductive relations. We can generalize about them, which we can project or find in the world. And so then, once we have a certain hypothesis, there will be all kinds of different evidence that might be relevant to that hypothesis, and but we use counterfactuals in reasoning about them. Okay, so more generally, it's not just counterfactuals, but more generally the contrast, this is the beginning paragraph in the middle of the second page of the handout on the projection strategy. The contrast between indicative and subjunctive conditionals is just one example of a range of modal concepts which come in pairs or pairs of families of words that express these ideas. Subjective or epistemic and objective. So it's familiar that modal might and must have a circumstantial and epistemic reason. We find natural necessity is reason about which we locate in the world, is necessity of some kind that we locate in the world, the kind that Hume was suspicious of and wanted explained. But the epistemic ones, for all I know, it might be, are much easier in some ways for the empiricists to understand. But may and might is just one, probability is another, familiar distinction between subjective probability, degree of belief, degree of credence on the one hand, and objective probability, chance, on the other, and the empiricist is comfortable with subjective probability, with degree of belief, sort of behavioristic accounts of how that works, more in the empiricist tradition. Skepticism about objective chance as being something that's dubious. There's relations of relevance and irrelevance, which are epistemic. Some evidence is relevant to some hypothesis or irrelevant to that hypothesis. There are notions of dependence and independence, which we locate in the facts. Facts are dependent on each other or independent of each other. Explanatory relations, causation is a kind of, the causal explanation is trying to use certain kinds of facts about the causal structure of the world to explain things, but explanation is also an epistemic notion. So one has a wide range, just looking at intuitions about modal concepts between these two kinds of things. And the general, as we saw, the general sort of empiricist bias, not bias in a pejorative sense, but just their principles of what needs to be clarification, is that the subjective notions are simpler and easier to understand, and we want to somehow use them to help understand the more objective ones to the extent we can at all. And one of the sort of ideas here then is to take the objective concepts generally to be projections of the subjective ones onto the world, the epistemic ones onto the world. Now, the interesting thing about the projection strategy is that it begins as a kind of explanation for a mistake, right? And all the examples I'm going to give are examples where at least one proponent of the view regards it as a kind of error, the projection, as if, but I'm going to suggest there's an alternative way of understanding the projection strategy, which is more constructive and less critical. Okay, so starting with Hume on causation, which is the sort of starting point of the idea here. So quoting Hume again, on the whole, necessity is something that exists in the mind and not in objects. Nor is it possible for us to form even the most distant idea of it considered as a quality in bodies. So the idea is the problem with the idea of natural necessity is it's a projection of an idea which essentially has to do with relations of ideas onto the world, to sort of locate it in the world where it doesn't belong. So the Humean distinction between matters of fact and relation of ideas, ideas are connected in semantic, we would say, he emphasizes the sort of mentalistic side, but more contemporary, or not contemporary, but modern empiricists would have put the emphasis on semantic relations of ideas. So the idea that one proposition entails another, or the application of one concept entails the application of another. This is a relation of ideas of things, but it doesn't give you any conclusions about distinct matters of fact. So no relation of ideas can give you a connection between, or be a rationale for a connection between one event and a distinct event taking place at a different time. So causal connections, which are connections between distinct events, the very idea that there should be a necessary connection is a mistake. So again, the idea, we start with the idea that Humean presupposition that all ideas are copies of impressions, or somehow reducible to things that are copies of impressions, then the notion of necessity is not an impression, it's something wholly in the realm of ideas, and so it's not something which can give you an idea at all. You can't form any idea at all involving the notion of necessity in a coherent idea of connections between facts. Now, but Hume goes on to say, well, this isn't a quotation, but necessary connection properly understood is a relation of ideas, while you cannot, according to Hume, form a coherent idea of necessary connection between facts or events. we can explain the source of the illusion that we have such an idea. So the source of the illusion, the illusory idea, is a projection of something in the mind onto the world. And here we have the kind of associationist psychology, which says, you keep seeing event of type A followed by event of type B, and you form an association which brings it about that when you have the one idea, you tend to have the other one as well in either direction. And that association you take to be something you find in the world, whereas it's actually something that just arises and is explained in terms of psychology. Now, many people who are not sympathetic to the Humean whole project would say, Hume is giving a causal explanation for why we have the idea of causation, which is an illegitimate idea. So the associationist psychology is a causal theory. And I think in some ways Hume would not have disagreed with that. So there's got to be some sense in which causation is a legitimate notion if we can go on comfortably and use it. And of course there's a familiar tension, which all the Hume scholars talk about, between Hume's naturalism, his psychology, and his overall theory about the nature of the mind, on the one hand, and his skepticism on the other. So skepticism about causation goes together with using causation in your theory. And Hume gives what he called a skeptical solution to problems about causation and problems about induction. Now, what exactly is a skeptical solution is somewhat, in general, somewhat obscure, but the basic idea of Hume's theory was, or Hume's explanation was, look, we have a skeptical argument that no inductive principles can ever be justified, but we also find ourselves in a situation where we can't help forming beliefs about the world. It just happens, and we have a causal explanation for why it happens. So we have a skeptical argument, which is sort of viewed from the inside, trying to give a justification, making no assumptions for using the principles we use. We say, we can't do that, but we can do something else. We can describe ourselves and how we form beliefs, and we can theorize about it. In theorizing about it, we're using inductive principles, and we're using the notion of causation, and we're using those notions partly to explain how we get those ideas. So we shift to this external perspective where we take for granted that we have beliefs and we can reason about them using our inductive procedures. We'll see there's something very similar in the way Goodman talks about induction. But more explicitly, I mean, with Hume, it's really hard to reconcile the things he says in different parts of his theory. So, but at least in terms of thinking, just focusing on this narrow notion of projection, one way to resolve, this is on the third page of the handout, one way to resolve the tension is to give a more positive interpretation of the very idea of the projection of mental associations onto things in the world. That is, to explain it as a pattern of concept formation rather than as a confusion of categories. And again, I'm not suggesting that Hume would reconcile the views. It may be difficult to explain so many of the texts on this hypothesis, but I think it's a way of making the different things fit together, even if they're not his way of making them fit together. But one of the things that's clear is that when he's in his naturalistic mode, Hume puts great emphasis on the role of causation in inductive reasoning. So the final quotation in the Hume part of this, all reasoning concerning matters of fact seem to be founded on the notions, on the relation of cause and effect. By means of that relation alone, we can go beyond the evidence of our memory and our senses. So we can go beyond our evidence. We can make inductive inferences. We just can't justify them. And if we give a more descriptive account of what we're doing, then we say we can note that causal concepts play a crucial role in that reasoning. So there's got to be something legitimate about causation, according to Hume. Maybe a sort of different part of it that Lewis, in his picking up of Humean themes, emphasizes is the reductionist part, the part that, well, while there's no necessary connection in cause, there are regularities. But the regularities don't help us to explain inductive procedure. We can use, if we could know regularities, then we could use them in inductive reasoning. But how do we know them? So we don't have any kind of explanation for why our inductive procedures work. Okay, so second example, and this is something I'm going to talk about on the last in the last lecture on Friday in more detail, is the notion of dispositional properties, and in particular what Goodman has to say in Fact, Fiction, and Forecast about dispositional properties. So one motivation for the search for a reductive analysis of counterfactuals originally for Goodman, as we talked about, was to provide us with resources for the analysis of dispositional properties, such as fragile, flexible, observable, and so forth. And Goodman thought the range of concepts that are dispositional was extremely broad. So color properties are dispositional, according to Goodman, because he took the color experiences to be more fundamental, and to find color in the world is to find properties which dispose us to have certain experiences. So it isn't just the ibble and the obble words, he says, that are dispositions, but a wide range of properties. And this goes to kind of what Ayer emphasized in talking about what he took to be the reductive base for, is that any kind of talk of the objective world is talk about dispositional features of the world, and we explain how we test for those things in terms of counterfactuals. Okay, so the Goodman says, after his acknowledged failure on his own terms in giving a reductive analysis of counterfactuals, says maybe, or I suspect, that the problem of dispositions is really simpler than the problem of counterfactuals. So the idea was to turn to that problem rather than to try to explain counterfactuals first. Now, why might it be simpler? We'll see why the analysis of disposition in terms of counterfactuals has counterexamples, as much discussed in the literature on dispositions. But part of Goodman's reason for taking more is that the logical structure of dispositional predicates is much more straightforward, unproblematic, than the logical structure of counterfactuals, which is obscure. And that's what the sort of logics of counterfactuals that were developed helped to clarify that problem. But at Goodman's time, there's sort of no understanding of exactly how the logic should work, or whether there was a clear way the logic should work. But predicates are just predicates, right? Monadic predicates. So the disposition, the property of being fragile or flexible, is simply a property. And we know that its logical structure is to have an extension and to, I mean, Goodman was skeptical about properties and intentions, but if you're not, you can say it's to express a property. A dispositional predicate expresses a property. And it's clear enough what a property is. It's something that is, things have under certain conditions. So one of the reasons for thinking disposition might be simpler is their logical structure is simpler. But also, I think the main thing he does in going on to look at the problem of dispositions is not to look for a reductive analysis of dispositions, but rather to simply connect them with inductive procedure. So think of what we're doing when we do inductive inference. We have an observable, we have a bunch of observations, and we project the generalizations we find in the observations onto the unobservable. That's what inductive inference is. So one way to see it is the projection of observed regularities onto unobserved regularities. And the problem of induction is the problem of what are the generalizations we use to do that. So Goodman noted, you can't solve the problem of induction along the lines that Hume wanted to solve it. You can't give an analysis of why, a justification from the inside of why we should use certain inductive, we should take nature to be uniform in certain respects and not in other respects. But what we can do is describe, and this is something like Hume's shift to the skeptical solution, we can describe induction. And it turns out to be a lot harder than you might think to describe induction. So Goodman's constructive project concerning induction, as developed in the later chapters of Fact, Fiction, and Forecast, was to try to state the rules by which we make inductions. And it turned out you needed to distinguish certain predicates from other predicates, Grew and Bleen-like predicates from red and green and blue-like predicates, and we needed to explain how we make that distinction. So, but the main thing that he does in addressing the problem of induction is say, look, the relationship between observation, what's observed and what's unobserved, which is essential to inductive reasoning, is also involved at a conceptual level between, well, he wouldn't have put it in terms of concepts and all, but in the way we project a concept onto another concept. So we have the distinction between things that flex and things that fail to flex, which are all things that are subject to a test condition. Some of them pass the test, others fail. But then there's a bunch that are never subjected to the test condition. So we say, we hypothesize that there's a property, although Goodman wouldn't have put it this way, that explains why certain things flex and other things don't, but it's a property that things have even if they're not subjected to the test condition. That's an empirical hypothesis that there are such properties. We say whatever the rules are for justifying this kind of projection, conceptual projection of extending our, of introducing predicates which have the wider extension based as a generalization of predicates that have a narrow one, whatever rules we use to do that are exactly the same rules we use to make inductive projection from the observed to the unobserved. So we haven't solved the problem. The problem of induction, the descriptive problem of induction remains, but we've tied two problems together. The problem of conceptual projection that's involved in dispositional properties and the problem of induction. So I take this to be a paradigm example of the projection strategy, but regarded as a more positive contribution rather than as simply as a criticism. So it's not that in the mind we make inductive inferences and it's a mistake to think that there's something in the world that goes with them, but it's rather the same procedures for justifying the claim that there is something in the world is the same process is involved and is legitimate in the, we should think legitimate in the one if it's legitimate in the other. Okay, third example of the projection strategy, and this is the example which is not closely connected to the problem of dispositions, but a very specific theory by a distinguished Italian, not really a philosopher, but philosopher and statistician, theorist of statistics, which is a kind of projection of subjective probability onto the world to form a notion of objective probability. At least that's one way to understand one upshot of a mathematical result that Bruno De Finetti develops. So let me just describe, and we'll talk a little bit more about this in the context of theorizing about dispositions, but describe the representation theorem, which is a purely mathematical result, and then look at one kind of interpretation of it. So what De Finetti proved was that given certain assumptions about the structure of a purely subjective probability function, which represents degrees of belief, one could represent that credence function as a mixture of probability functions satisfying a stronger condition. That is, the mixture means you can say the probability of such and such is equal to a weighted average of a bunch of other probability functions weighted by some parameter. I mean, that's the mathematical result, and the conditions which the initial probability function has to meet is that the probability function is defined on a set of basic events or propositions, as philosophers call them, statisticians call them events, but they're proposition-like truth conditional things, are all events which are exchangeable. And I'm not going to talk here in detail about exactly what that means, but but the rough idea is very simple. It's that take any conjunction or disjunction of events of this kind and permute all the basic properties with each other, and the probability of the permuted proposition or event will be the same as the probability of the original one. So the idea is take something like, suppose the events are an infinite sequence of flips of a coin of unknown bias. The probability of 3 heads in a row followed by 6 tails is the same as the probability of any sequence of 9 flips, which consists of 3 heads and 6 tails. Here you can sort of permute the whole thing and take any part of the infinite sequence, and that will have the same probability. That's what it is for the events to be exchangeable. Okay, so then the claim is, if we have a sequence of exchangeable events, a probability function which satisfies the test condition of exchangeability, then that probability function can be represented as a mixture of probability functions where the events are stochastically independent, much stronger condition. So the events are stochastically independent just in case any conjunction of events is equal to the product of the conjunction of the separate events. So the probability of heads on flip 7, heads on flip 9 is equal to the conjunction of the probability of heads on the one flip and heads on the other. And of course, all the heads events will have the same probability, but also their conjunctions will have reduce it. So you reduce it all to the probabilities of the single events. Now that's a much stronger condition, but it's a condition which would be satisfied by a chance function. So suppose we had a sequence, suppose the sequence of events was a chance sequence with an unknown bias of the coin. So the coin, say, might have a bias 1/3, as a matter of fact. Then the probability of 2 heads in a row would be 1/3 times 1/3. So the stochastic independence condition would be met even if the coin was biased. So the idea is that the sequence of flips is independent stochastically, just in case the coin doesn't change as we go. It retains, in terms of the sort of using the uncritical notion of chance, it retains the property of having a certain chance disposition. Okay, so basically you could see Duffinetti's result as an argument that showing that you can always represent, provided your initial degrees of belief over a space of events which just involves coin flips, just observable events, because you can observe whether the coin lands heads or tails. So we have a sequence of observable events, and all the propositions definable in terms of those events can be given then a probability function, your degrees of belief about what's going to happen of each of those things. If it's exchangeable, then you could see this as if it were a case where you thought there are 2 facts. There's a fact about the bias, and there's the fact that the coin the flips are independent of each other, causally independent of each other. But that's all in the representation. There's nothing in the world, he said, about chance. It's rather that the events are just observable events, and that's your whole algebra, is those events. But you could see it as a distribution over chance functions defined on those events, where the parameters in the mixing are probabilities that this is the right chance. So if you had a situation where the coin is either biased for heads 2/3, 1/3, or biased for tails 2/3, 1/3, and there's a 50-50 chance of each, but we don't know which, then you would have an exchangeable degrees of belief on the events, and as you learn more and more, as you get more and more evidence about flips, then the parameters will change, and it will become more and more likely that the coin has a 1/3 bias, a 2/3, 1/3 bias in one direction or the other, depending on which it is. So then you can prove that you would actually be able to gather evidence about this unobservable fact, if it were a fact. Now, as I said, we can look more, this is not really a separate example from the dispositional case, it's the more specific version of it, because you can think of chance as a dispositional property, a dispositional property which is grounded in degrees of belief, that it's reasonable to have under those conditions. Okay, so now as I say, Duffinetti is a resolute subjectivist who regarded his theorem as explaining the appearance of objective probability. Why do we incline to think there's such a thing as chance? And we have this sort of robust belief, and it plays a role in our inductive theorizing. It's because we can interpret the appearance of this objective feature as something that's derivative from the properties of a purely subjective probability function. So the more constructive way, so Finetti thought this is an explanation of an error, how we can help ourselves to the notion of chance without really believing in it. But you can also see it as a more constructive account, as saying why, if there were such a property as chance, the empiricist is skeptical about theoretical properties. You can't observe directly the chance of a coin. All you can do is flip it a lot of times and then make some judgments about it on the basis of that. But de Finetti's theorem also helps to explain why, if there were such a property, then we would have reason to take the flips of the coin as evidence for that chance. And we'll be able to explain how the ordinary Bayesian reasoning, which involves hypotheses about chance, and the probability for Bayesian reasoning, where you take the probability of the evidence to be probability of a hypothesis given evidence is related to the probability of evidence given hypothesis, and we can explain how you use those kinds of things to do inductive reasoning. Okay, so the ideas here we have, recall A.J. Ayer's remark, it's only at some level of theory that we can form any picture of the objective world. Only in some theory that we can go beyond chance events, just the flips themselves, to something underlying them that explains them. But we need the theoretical resources provided by counterfactual conditionals, dispositional properties, powers, capacities, dependencies, in order to give an adequate description of the objective world. The anti-reductionist thesis about such ideas about natural necessity is not that there is a level of theory that is irreducible to the level of fact, but it's rather that there is no level of fact that is characterizable independently of theory, where theory here refers to powers, dispositions, relations of causal dependence, independence, and so on. And what the projection strategy suggests is that the process of forming a theoretical picture of the objective world proceeds sort of in interaction with, together with, the process of forming inductive policies by which we test and confirm that theoretical picture. So as Hume suggests, causal notions will play an essential role in our characterization of our reasoning about matters of fact. But we can't get any causal ideas until we've already done some inductive reasoning. So we've got to sort of march together with these views in forming inductive procedures. Now, the thing I'm going to emphasize in the last couple of lectures is the central role that a notion of independence, a causal notion of independence, plays in all of these stories, the story of Goodman's, the story of de Finetti's, and so on. And in general, you can say how a notion of independence plays a very strong role in our ordinary thinking about inductive procedure. Why do you need random samples? What is a random sample? So the idea is you use a property of a population to pick out a sample, which is known to be causally independent of the property you're testing for. Well, who knows what's causally independent of what, right? You might be not very knowledgeable about what the causal relationships are between things in this population. But one thing we know, if you take a randomizing device and select members of your population using that random device, that there isn't any causal connection between the properties of things in the population and properties of your device, which might lead to a bias of selection. And once there was an example of Henry Keiberg gave, of somebody who didn't bother to randomize. What they said is, well, we want to know how many Scotsmen there are in the population. So we'll pick a random part of the chunk of the phone book and just take all the people as our sample there. Chose the letter M, we'll just do the letter M. Found out there's a huge number of Scotsmen because their names all start with Mac, So if you just pick a property casually, you may wind up with one that happens to be correlated causally with the thing you're trying to test for in the population. But you're looking for something independent, and we have procedures, inductive procedures developed for ensuring that things are causally independent. So the role of causal independence in inductive reasoning is clear. So I think it's also clear that that's closely connected to an idea of the kind of closeness and similarity that we're looking for in finding criteria for selecting worlds to interpret counterfactuals. Okay, so we'll look more about the notion of independence. In particular, find out the notion of independence is also relevant to play and plays an essential role in practical reasoning. And that's another place where counterfactuals play a crucial role. So I'm going to emphasize next time, look at review some things about decision theory and game theory, and look at the role of assumptions about causal structure in those theories, and see something about how one application of the notion of counterfactual is to practical reasoning. And then we'll put it together with some talk of both practical and epistemic issues with dispositional properties on the fifth day. Okay, thanks. In sketching the so-called projection strategy that I talked about mainly last time, I emphasized the notion of causal independence and giving the examples, for example, Goodman's sort of way of thinking about dispositional properties that we'll talk more about next time, and in particular the attempt to sort of explain the notion of chance in the way I was suggesting. Causal independence played a central role. It also plays, I think it's intuitively a more robust, simpler relation than causation itself. Causation is complicated, exactly, and a lot of controversy about even given notions of causal independence. Although they obviously constrain the notion of causation, they don't yield a definition of it. So it's, I think, a more basic notion. It's also the role in epistemological reasoning of notions of causal independence. For example, in the whole idea of random samples and other sort of more specific kind of inductive methods that play a role in both common sense and scientific reasoning involve the notion of causal independence. And also, finally, the notion of causal independence is intuitively a closeness or yields a closeness relation or similarity relation of the kind that's relevant to the interpretation of counterfactuals. It doesn't yield a reductive account of one, but it does connect up with intuitions about closeness of possible worlds. So the main idea, at least as I thought of it, always thought of it, of the idea that you pick the closest possible world or a closest possible world, is the idea that you make in constructing a conception of the counterfactual world, you leave everything the same except what's needed to change to make the antecedent true. So if you think in this sort of intuitively, not as sort of selecting a world so much as constructing one, although that's not something one doesn't want to take too seriously, but constructing a conception of a world, you want to leave everything the same, tweak the world to make the antecedent true, but leave everything that you don't need to change the way it is. But what does it mean to be something you need to change? That's the whole problem, because you always are changing some things and leaving other things the same, no matter how you do it. So the idea of causal independence plays a role. So obviously, if something is independent of the antecedent, plays no role in the sort of causal chains involved in the events that one is changing counterfactually, then one leaves everything the same that isn't necessary to do that in the sort of effects of the antecedent. Now again, there's no explanation, but it's just a connection of intuitions with some other things. And in general, the strategy, the non-reductive strategy, is not to reduce the notion to something more basic, but maybe in some ways the other way around. That is, if we find a central notion, which itself is one of the problematic ones, if we can explain a lot in terms of it, a lot both of the function of counterfactual reasoning and so on, and use it to help analyze other notions, then we clarify a concept by using it to clarify or to connect with other concepts. So that's the general kind of strategy. More methodologically, the strategy as contrasted with a reductive strategy is going to be piecemeal. So the best way to try to, one good way to try to clarify the difficult concepts we're interested in is to find specific models which concern a particular kind of application. They normally, if you want to be precise, as we do, but there's always trade-offs in being precise, so you use models that are highly artificial and idealized in some cases, but ones that are concern a specific kind of issue, and then see what you can do in explaining how counterfactuals work in that limited artificial or idealized context. And we'll see that when you do that, it raises some problems of interest and also helps to clarify what's going on in a more general case, or at least that's the hope. So causal independence plays a role, I emphasize, in epistemic reasoning, but it also plays a central role in practical reasoning, and that's going to be the main focus, and that's the kind of models I want to talk about today is, again, artificial models of decision-making as developed by theorists who aren't focused in particular on counterfactuals. They're focused on the task of Bayesian decision-making. But there's lots of causal and counterfactual information presupposed implicitly in the characterization of in particular of games, but more generally of decisions. So a game, in the game theoretic sense of a game, is a sequence of decision problems, and the definition of a game imposes a lot of causal structure. It's a sequence, so we have a process, an evolving process in the course of the play of a game, with causal influences and causal independence involved in characterizing the flow of information and the flow of decision-making in the course of such a complex of decision problems. So I want to look talk first of all by just some exposition and contrast of some alternative versions of decision theory which contrast with each other in virtue of the role they give to causal structure in the characterization of what's involved in rational decision making. So we'll look first at different versions of so-called causal decision theory versus evidential decision theory briefly, and then look at the third framework for decision theory, which is connected, namely game theory, and think of game theory as a kind of application of causal decision theory. In the end, what I want to do is raise a problem about the relationship between determinism and the kinds of structures that are developed in the case of modeling decision making. A tension between determinism and these structures, which are also involved in the concept of chance. We'll look at the relationship between, the familiar philosophical problem of the conflict of determinism and free will is the most prominent focus of this kind of problem, but there's a more general problem about the relationship between counterfactuals and determinism, which I think it helps to look at to look at the relationship between the more general problem and the more specific problems about decision making and free action. Okay, so to jump in by first just looking at the basic ideas of Bayesian decision theory and see how causal structure is involved from the start, really, of the formulations of these theories. Then I'll talk about causation or causal independence, but it's implicit in the development of the theory. So start off with the basic idea of all versions of Bayesian decision theory is when faced with a decision problem, this is the start of the handout here, the outcome will depend on two interacting things. First, what are the alternative available actions to be chosen? So basically, you can think of what the theory is telling you is what do we need to know to have a decision problem? And what are the resources that the agent needs, the epistemic and other resources, mental resources, in order for it to make sense to assess the agent's action as a rational action, as the right thing, rational thing to do, relative to something, relative to what? So the decision theory is going to spell out what we need to assume in order to, what assumptions we need to make in order to have a context in which we can specify what's rational. Okay, so in a realistic situation, it's going to be difficult to say, well, what are my options? What can I do in a particular situation? But in giving a kind of artificial model, you say the first thing to do is to get an understanding of what you regard your options to be. And the theory will assume that you know what your options are, what you can do, what's available to you to do. The outcome of your action, the outcome of your choice, which of the alternatives you choose, the outcome will depend not just on what you choose, but also on facts in the world, which may include unknown facts about the world on which the outcome depends. So if you choose to accept a bet on a certain flip of a coin, then you know that the outcome will be either you win and wind up richer than you were before making the bet, or you lose, winding up poorer. So you accept the bet by paying down the amount you need, and then you either win or you lose. So the outcome, the good or the bad outcome, depends on a fact which over which you have no control. That is, you have control over whether to bet or not, but you don't have control about whether the coin lands heads or tails. Maybe you have control over whether the coin will be flipped, because it won't be flipped unless you bet. But once you choose the bet, the outcome of the coin is not affected by that. Okay, so that's the very rough intuitive idea, and then you say, okay, so what we need is a characterization of two things. What are the available options, and what are the possible states of the world, states which characterize the relevant facts about which you may be ignorant. Since you may be ignorant of them, what you need in addition, since obviously it doesn't matter just, whether you win or lose depends partly on what you think about the coin, that is what your beliefs are about the coin. So you have partial beliefs, probability beliefs, subjective credences or subjective probabilities in the relevant facts. So you specify a probability function which represents, in defining the decision problem, which represents your ignorance, your degrees of belief about the alternative states of the world on which your outcome, the outcome of your choice, will depend. Okay, so if there are, say, 3 alternative actions and 4 alternative states, then you can take each of the pairs consisting of an action and a state and ask, what's the outcome or the consequence of that pair? If you do choose action A in situation S, what do you get? What happens? Or what value do you put on that? So you've got to specify the values for the consequences of your possible consequences of your action, probabilities on the states of the world, that where states are understood as causally independent, in particular situations about the world which are causally independent of your action choice. So you have a kind of two-dimensional matrix with actions on one dimension and states on the other, with the utility values of the consequences written in the boxes in the matrix. So then how do you decide? Because the action does well, sometimes not well others, and you say, take the, what you should choose is the action that gives you the best expected utility, expected value, expected desirability, whatever you want to call it, where expectation is understood in a usual way, as in statistics, as a weighted average. So you have a weighted average of the value of an action will be a weighted average of the values of the outcomes, weighted by the probability or credence in the state. So if you think the coin is heavily biased, or maybe 2/3, 1/3 biased for heads, then your degree of belief will be 2/3 that it will land heads and 1/3 that it will land tails. So you're going to bet on heads if you bet, and your action would depend on what the odds are. That is, what do you win if it's heads, and what do you lose if it's tails, and you would just take the weighted average. So that's the standard general characterization, and I'm describing this in terms of states and actions using the terminology introduced by Leonard Savage, whose version of Bayesian decision theory is the most sort of influential among statisticians who are applying these Bayesian techniques to statistical reasoning. So central, I mean, the thing I want to emphasize here is central to this way of thinking about decision theory is a notion of causal independence, that one finds features of the world. Some features of the world will be affected by your actions, others will be unaffected, and states will be the state of the world that's unaffected by your action. Okay, so that's, but when Savage spelled out this version of decision theory, it was a very, it was not a, it was designed partly to motivate certain representation theorems, but the formalism was intuitively quite artificial in certain ways. In particular, the notion of an act or an action was simply defined. We had the primitive notions were notion of consequence with the outcome, possible outcomes. What do you get in the end, on the one hand, and actions, or rather states, on the other. So states were primitive, consequences were primitive. Acts were just functions from states to consequences. So it's clear that if you think of it in the way I described it, as sort of a matrix, you can say, well, if you start with the consequence and the state, then each act will determine a function from states to consequences, because you just look at each of the states and ask what are the consequences for that state. But of course, acts are not some kind of artificial function. What they are is things you do. So it's a more sort of elegant and uniform formulation would treat actions, states, and consequences all as facts about the world. So it's a fact about the world that you choose one action rather than another. It's a fact about the world that it's in this state or that state. And the two things together determine a fact about what the consequences are of your action. So Richard Jeffrey was not happy with not just the inelegance of the Savage framework, but also with the role played by causal notions, being an empiricist who is skeptical of causal concepts. So his formulation of decision theory tried to avoid any reference to causal notions. And it also provided you with a kind of uniform framework. So you start with for Jeffrey's formulation of decision theory, you start with a state space, which is the same as a set of possible worlds. I'm not necessarily sort of complete possible worlds, but just sort of a partition of the possible states of the world into all the relevantly different ways things could go. So in terms of the sort of model here, so you think of this rectangle representing the state space, and each action should be thought of as a proposition, the proposition which is true in worlds in which you choose that action. Okay, and then the Savage kind of notion of states cuts across, and the consequences are, so you say, you put in a number here, a utility value, and so on, and then and then you have a probability assignment here. In Savage's theory, in Jeffrey's version of the theory, forget some specific identified partition of states, and just think of a state space divided into actions. Then take any proposition, so draw one without the states here, we have take any proposition represented by some subset of the space, and we can say, what is the value of this proposition? So take any proposition at all, including an action proposition or something that has some causal properties or whatever. Take any proposition. The Bayesian decision theory will be defined in Jeffrey's theory independently of any assumptions about the relationship between these propositions and this other one. So, but the same principle of expected value is applied. So you say each subset of the space of possibilities has a value, a utility value. So there's no sort of one thing that's the consequences. There are any proposition, you can say, what is the value of that proposition? Now, the value of a proposition depends entirely on how it is, intuitively, on how it is realized. So if I say, consider the proposition that that we go on a picnic tomorrow or something like that, and I say, well, if it rains, that'll be a big mistake, so it'll have a low value in the context where it rains, and it'll have a higher value in the context where it doesn't. So in general, take any proposition, quite independently of any actions or anything else, and say the basic rule is that the value of this proposition is a weighted average of the value of its subsets. So, and we don't start with sort of values assigned to cells, primitive cells or worlds or anything like that. We start simply with the constraint in your value theory that the value of a proposition is a function of the ways it could be realized. So that's a global constraint on utility. But in the particular case where we're looking at this proposition and these values, then the value of this proposition will be a weighted average of these, weighted by the probability of that. So you can see the Savage theory is really a special case of Jeffrey's a kind of a generalization of it, but the point is that you don't need to make any causal assumptions. There's no particular partition of the space into states that plays a special role. So causal independence is playing no role in Jeffrey's theory. Okay, so in this context, we have a kind of inelegant but interesting causally loaded version of decision theory, a much more streamlined theory formally, but also leaching out the causal assumptions in the theory from Jeffrey. And this, and it's interesting that philosophy, I mean, it's sociologically interesting that the philosophers were often brought up on Jeffrey after he wrote his Logic of Decision, and that was what they thought of as basic causal decision theory, or basic version of Bayesian decision theory. Whereas statisticians didn't pay a lot of attention to Jeffrey. They were brought up on the Savage kind of way of thinking, or on some alternatives to it. But then David Lewis comes along and formulates what really, in the end, is a version of Savage's theory with respect to with respect to the significance given to causal notions, but formulated in a kind of framework which is more like Jeffrey's framework. And as Lewis and other sort of developers and defenders of so-called causal decision theory that came later, Lewis thought of Jeffrey's theory as a value theory, not a decision theory. So if you want to say, you can reasonably say, for any proposition that you might learn, say, how good is the news for you that that proposition is true? So suppose you just learned that you missed your airplane, right? Is that good news or bad news? Well, bad news. But there's a piece of that proposition, a subset of that proposition, which it's good news, namely the one where the plane crashes. So there's a possible world where you miss the plane and it crashes, in which case you put a high value on that. Cases where everything goes normally and you would have reached home earlier and less inconveniently is good news. So in general, you can ask simply about the value of a proposition that might be realized in alternative ways and say, well, whether it's good news or bad news that that proposition, if you were to learn that that proposition is true, would be a matter of variation from case to case. But the overall thing is say, well, I'm almost certain that the bad outcome won't happen because, we take for granted that it's extremely unlikely that the plane's going to crash. That's why we take them. So the probabilities of the alternative ways which the proposition can be realized are themselves playing a central role in evaluating the proposition simply as a fact, as a possible fact. So Jeffrey's value theory is defined quite generally, not just for acts, but for anything. But given that acts themselves, the actions that are available to you, are propositions, or represented as propositions, the proposition that you perform that action, that you choose that action. So the value theory tells you what is the value of an action. What if you learned, maybe you forgot what you did, but you learned that you chose action A1. And then you can ask, is that good news or bad news? Saying you know everything that you knew at the time you made the choice. Jeffrey's decision theory says choose your actions by choosing the option that would be the best news if you learned it, that you did it. So the evaluation of passive propositions, the assessment of the value of a proposition, is the same as whether the proposition is in action or not. So what Lewis does is say, I want to buy Jeffrey's value theory, but reject his decision theory, saying don't choose an action as the one that would be the best news, but choose the action that would tend to cause, or would, if you were to choose it, it would bring about a situation that's better than what would be brought about according to your assessment of what would happen. So if you just put the contrast starkly, one of the ways to put it is to say the expected utility of an action, say there are two, we divide the possibilities into two parts, S or not S, and we say it's the value of A and S times the credence, the probability of the part of A, which is in no. Plus the probability of not S times the value of A and not S. Okay, so take a weighted average relative to S, where S is any way of dividing the thing at all. Lewis's formulation doesn't appeal in some versions to a particular notion of state, rather says instead of the probability, the conditional probability, which is an epistemic notion, we should take it to be, and this is evidential, just one way of understanding it, the probability for the agent of the counterfactual times the probability of okay, so the contrast between Lewis's theory or other versions of it is, for Jeffrey, we take a purely evidential relation, and for Lewis, we take a causal, a counterfactual dependence relation. If it turned out that you know that you're dealing with savage-like states which you know to be causally independent, then these two things will be the same. But in general, they will be possibly different. Okay, so which version is right? And this is where the causal decision theory in particular was designed with a certain particular, very famous decision problem in mind. And it's interesting, the decision problem was formulated, which is Newcomb's problem, formulated by Robert Nozick, who was very much get Jeffrey's theory to be the right theory, or not the right theory, but the sort of given or standard theory of decision, Bayesian decision theory. So Robert Nozick posed the problem as one that suggested that, at least on a certain way of thinking, Jeffrey's theory yielded the wrong conclusion. Okay, so let me sketch the Newcomb problem. Most people will probably be familiar with it. It's been around for a long time. And it's something that created controversy because, first of all, the intuitions about the example vary from case to case, and also exactly what the theoretical consequences are is something you can debate. Okay, so but just to quickly describe the problem, and then you can think about what you think about this. You're presented with two boxes, an opaque box that contains either $1 million or nothing, and a transparent box that contains, as you can see, 1,000 euros. What did I say? 1 million euros, right, and 1,000 euros. Your options are, first, take just one box, just the opaque box. Forego taking the transparent box. That's one option. Your second option available to you is to take them both, take the contents of both. The money is already in the opaque box or not. So your choice, and this is the causal assumption, your choice has no causal effect on the amount of money in the box. The amount of money in the box is causally independent of your choice. So if you think in Savage's terms, it's a state of the world, that the money is there or it's not. And you have to think, what are your degrees of belief about that state of the world if you're thinking in Savage's way or in Lewis's way. So then the final part of the story is, how is it determined whether the box contains $1 million or not? And the answer is a predictor who is actually very good, very reliable, predicted what choice you would make. And on the basis of her prediction, she put $1 million in the box if she chose that you would pick just one, and she put nothing in the box if she chose that you would, if she predicted that you would choose both. Now the story about the predictor is not someone with magical powers. It's not someone who can see into the future. So there's no idea of causal influence of the future on the past. It's rather that there have been extensive psychological research done on this problem, and it's turned out to be very highly correlated with a certain score on a personality test or a cognitive test of some kind, which you have taken, although you didn't know anything about the problem at the time you took it. So the predictor based her prediction on the results of your test. But you have no idea initially what test result was, or even what the test was important in it, and so on. All you know is the problem you've just been given, and the evidence which everybody is given who has this problem, has faced this problem in the evidential base, knowing that you, knowing what the predictor has been very reliable based on this kind of evidence. So the argument is that if you go with Jeffrey's decision theory, then you say that conditional on learning, on the choice of picking both boxes, that gives you high evidence, a great evidence that you are, if you choose one box, that you're the one box type, and so probably the predictor put the money in there. So your conditional probability on the choose just one choice is high that the money's there, whereas your conditional probability on the hypothesis that you make the both choice is low. So if you do the weighted average this way, then you get the choice pick both boxes having much greater expected value, assuming that you like money. And that's really all that matters in this case. On the other hand, if you go with the causal decision theory version, then you get a contrast between what you would think if you learned. Suppose you made your choice and you woke up and you forgot what you choose. And you say, what do I hope I chose? And you say, well, I hope I chose just one box, because then I probably will get the money. But if you are actually faced with a choice, according to the causal decision theorists, you should go with the choice of both boxes, because the counterfactual, since it's counterfactually independent, whether the money's there in your choice, you can say, suppose I'm the one box type, then if I chose two boxes, then I will choose, maybe, I'll probably choose one box, but if I were to choose two boxes, I would do better. So you have a dominance argument because of the causal independence of the assumption. So on the assumption that the money's already there, if the money is there, then I do better to take both. If the money's not there, I also do better to take both because I got 1,000 rather than 0. So you have a kind of dominance argument that we don't have to worry about whether the money's there in terms of assessing the rationality of of the choice. Okay, so, people, you can sort of give various thought experiments and arguments, making it plausible that the choice should be one way or another. One could say, suppose you're making the choice and I'm sitting here, I'm your advisor, and the box is transparent, both boxes are transparent in this direction, but opaque, one of them in your direction, so you can't see whether the money's there, but I can. But I'm not allowed to tell you. But I am allowed to give you advice. Okay, so what advice am I going to give you? I look in there, I see the money, I say, take both. I look in there and I see no money, I say, take both. So you don't need an advisor. You already know you should take both, because that's what a person who has your interests at heart, who knows more than you do, would tell you. So, there's the argument of that kind in defense. Other arguments that notice that the one boxers all get rich and the two boxers don't, so wouldn't it be better to be one of the rich people? And the two boxer says, yeah, it'd be nice, but I happen not to be, that happens not to be an option open to me because I'm not that type. Okay, so that's the contrast. Now, when you can think about, I'm not going to go, I want to use the Newcomb problem mainly just to illustrate the contrast between the two views. Now, a game has, even though game theory developed somewhat independently of Bayesian decision theory, it still used the notion of expected value, although using objective probabilities the way it was thought about. So a game is a sequence of interacting decision problems. And in defining a game, unlike defining a Bayesian decision problem, you specify utility values for the outcomes of the game, but you don't specify for the different players, but you don't specify the probability values. So the idea is supposed to be what you know about things you don't control are what you know is what the other person's values are. So you know the other person is going to act rationally. So if you figure out what's the rational thing for the other person to do, then you can predict that the person will do that. Or if you think it's probably probably the person's rational choice is this rather than that, so probably they'll do this rather than that. So you base your decision on, again, what corresponds to states of the world are other people's choices. What corresponds to your choices are the options available to you. So the specification of the game specifies options for the different players and doesn't specify what you believe about the other players in a quantitative way. It just specifies that you believe they're rational. So best way to think of game theory, I think, although it wasn't originally thought of in this way, is as a partial specification of a sequence of decision problems. You can define a model for a game which fills in the rest of what you need to know to determine what's rational to do, namely beliefs or credences that you have in the other person's actions. Then you could add a general constraint on the theory, but let's suppose that you know, or that it's common knowledge, or other assumptions you can make, that all the players act rationally. Then you can say, what kind of model of a game what would people do? What are the constraints on what people would do in some model which meets that constraint? So that's the sort of Bayesian way of thinking about the application of game theory. Now, a game generally will be defined by a tree structure where you label the tree by the player. So player A gets to choose left or right, player B gets to choose left or right, and then player A gets to choose again. And then in all the possible final outcomes, you put in a utility value for each player. And then you think, what will the player do given that they're rational? And you say, well, it's clear enough what A will do if he reaches that point, but maybe he won't reach that point because maybe B will choose here. So in order for A to figure out how to assess the difference between the best value here and compare it with the best value here, has to make a prediction about what B will do. And that prediction can be based on what A knows about what B's values are. So we have to think, what will B get if this is the outcome versus what will B get if one of these is the outcome? And say, well, player B's choice, given that player B is rational, will depend on that utility. So player A uses B's values to predict, to make an epistemic commitment, and uses her own values to predict, to choose which of the options, and so the interaction of those kinds of things. Now, so you can add some further complications which involve, in order to get more interesting games than the pure perfect information games, which involve a further consideration of causal independence. I mean, the point is here we already have in the tree structure some assumptions about causal independence. Nothing B can do will affect what A did first, but what B can do will affect what A does next because A won't have a choice. Or even if A did have a choice, a further choice, B can affect A's action by choosing something because A will choose one thing one way if he's here and another way if he's there. So you have causal structure built in to the story. Now you can add an assumption that A has to make her last choice, should she get there, in ignorance of what B did. So this is an assumption of causal independence, is to say we can add a constraint, a so-called information set, which says A's choice is counterfactually independent of B's choice. So A doesn't have the option of choosing this on this possibility and that one on that. These are be linked. So this is a single choice point. A can either choose to go left, whichever place he is, or to go right. And that's an assumption of causal independence. So the definition of a game builds a lot of causal structure, and that causal structure plays a role in determining what the options, what options are available to the player, and what the consequences of the actions, the way in which they depend on each other. So after defining games in this extensive way, with tree structures, Von Neumann and Morgenstern, when they first invented game theory and developed it in the 1940s, suggested that we can give a more abstract formulation of the theory, the so-called normal or strategic form of the game. And I'm going to talk next time some about strategies. A game in strategic form is something that looks more like one of these matrices. So we might have A will have 3 strategies, say, and B will have 4 strategies, although that's not this game. In this game, A has either the strategy of go left first and right second and so on, or whatever, and B has the strategy, just one choice, or in the simple game. But in a game with many moves, your strategy will be a choice at each possible point that might arise. So you can say, and this is the way von Neumann and Morgenstern justified the idea that the strategic form represents all you need to know to determine what's rational. They say, suppose you're going to play one of these games and you know perfectly well what the tree structure is. But suppose instead of playing the game in real time, we say that we have a referee, and you are to turn in a strategy to the referee saying what you would do in each of the possible circumstances that might arise. So what would you do if you reach this choice point, and what would you do if you reach that choice point, and so on. It's for every choice point that you might face, you choose one of the options, and that's a strategy. So a strategy is a complete specification, not only of what you will do, but everything you would do if the occasion were to arise. So again, a counterfactual built into the characterization. So the idea is that in an ideal situation, choosing a strategy is rational if and only if making the choices dictated by the strategy would be rational in each situation that were to arise. So we could play the game in this boring form where you turn in your strategy first, and then the referee plays out and says, here's the outcome. Right? So here the idea is, if you represent it in this matrix form, we have a very clear representation of all the complex causal interaction is sort of reduced to the dispositions that the player has at the start of the game. And so the idea is that the game would unfold by perfectly rational players in exactly the way that will yield a decision made in this form, the strategy choice form. So the idea is that here, and to put this into the more Lewis and Savage way of thinking about decision theory, for Alice, these are her options, and these are her dependency hypotheses or states in Savage's sense. These are the facts that Alice can't control, namely what Bert's strategies are. And similarly, Bert's actions treat these as states. So the sort of state-action contrast in the classic versions of decision theory are reflected in the game. So again, causal independence, and and also the idea that the world unfolds as a result of the dispositional states that it has at an earlier stage. So this sort of dynamic pattern is reflected in a static version of the game. Now, there's a lot of controversy, and in particular, enormous idealization needs to be made to get the equivalence of the normal form and the strategic form. In fact, in playing out in real time, you don't make hypothetical decisions about what you would do in situations that aren't going to arise anyway. You'll make them as you go. It's much more efficient. But the extreme idealization of the theory just sort of abstracts away from all that. So in particular, if you were to think of chess as a game, and with a definition, there are each player has a certain number of complete strategies, and the number of strategies that each player has is greater than the number of atoms in the universe, right? So if you weren't making sort of the assumption of logical omniscience, perfect computational power, nobody could ever play a game in strategic form if the game has any complexity at all. In fact, from an ideal point of view, chess is really not that different from tic-tac-toe. Because tic-tac-toe, you really could spell it out. The only difference is chess is more complicated. And so it's harder to figure out what the ideal strategy is. And in fact, it's even harder to figure out, theoretically, who has the ideal strategy. So it could be that white could always win in chess if he played ideally. And it could be that black could always win, or it could be that it will always be a draw, probably the last. But But there's some games where if you go first, you lose, and if you play ideally, and the other player does, and others where if you go first, you get to win. So the idealization is ridiculous in some ways, but still the games we look at in order to reveal certain features of strategic reasoning are often simple ones where the idealization is not so extreme, and one can learn something about strategic reasoning generally from those kinds of games. Okay. All of these ways of thinking about decision theory and all the ways in which causal structure is built in involve this kind of tree structure, branching structure of some kind. And this applies to chance as well, because you can think of chance, a chance model, as an evolving sequence, say, of events where chance changes as we go. A chance model as a kind of special case of a game, a degenerate case of a game where there are no players other than nature. But you have the same branching structure with a chance here and then a chance there and so on. Probabilities assigned to the branches in the tree. So the branching structure, together with some further assumptions about causal independence, play a central role in the characterization. But the question, the sort of general problem I want to raise about determinism is how do we fit this sort of branching idea, this idea that there are alternatives at various points in the course of a sequence of events, with determinism? David Lewis asks us to consider, and this is a general problem, not about games, but about, or decisions, but about the relationship between counterfactuals and determinism. David Lewis asks us to consider, and this is the last page of the handout, a counterfactual that supposes that some ordinary actual event did not happen. There's an antecedent, counterfactual antecedent about an event, any event. Suppose I had not blinked at a particular time when I in fact did blink. Determinism seems to imply that the counterfactual world which I choose, or the counterfactual worlds that I choose, the closest ones in which I blink, have to be either ones where the history, the events in the past were different all the way back in some respects. Because if they ever were the same at some point, even no matter how far back, then determinism would say that I blink, would entail that I blink, assuming the laws are true. So either the world was different all the way back through time. If I had blinked, things would have been different a million years ago. Or an event is, a law of nature is violated in the actual world. If you then think of this in terms of action, you think, when I'm choosing whether to do A or B, do I have the option of falsifying a law of nature? Or do I have the option of altering the past? Because is it true that if I were to make the alternative choice from what I'm going to make, then the past would have been different, or a law would have been broken. Both of them seem grossly implausible. So there's a question, there's a tension between a kind of law-based theory of the causal structure of the world, and which in some ways one thinks that determinism is sort of, you can't change anything without changing everything. Right? There's no sort of ways to divide things up in the way in which counterfactuals seem to require that you do. And the problem is particularly acute when we're talking about what we regard as free human action. And this is a real puzzle, I think, and I don't know exactly what the general response to it should be, but I do want to suggest that at least intuitively, the distinction concerning causal independence it is not incompatible with determinism. So I use this little example to illustrate this. Alice accidentally dropped a flower pot out of the window, third floor window, in exactly the moment when Bert was passing below, so it hit him on the head. Few people walk by this street, so it was a rare event that there was someone there. Rarely does Alice drop a flower pot. I mean, she just happened to this one time. So it was a remarkable coincidence that Bert just happened to be there at the wrong time. It seems intuitively clear, if one just thinks intuitively about counterfactuals, that if Bert had left on his walk just a few minutes later, then the flower pot would not have landed on his head. Because the way we've told the story, Alice's event was independent of Bert's, causally independent. That's to suggest that the causal chain leading to Alice's dropping the pot would still have been true in the counterfactual world, which we define as the one that would be if Bert had left on his walk a little earlier. Now, this assumption about the causal chains is wholly compatible with determinism, because what determinism says is the whole history of the world, if it were the same at some earlier time, then that means Bert's causal chain and the causal chain leading to Bert's being there and the causal chain leading to Alice dropping the pot would each be determined, even though completely independently, by the same global state of the world. But that's compatible with saying that nevertheless the chains are different. So that it seems the idea of holding certain things fixed and not others is perfectly compatible with determinism. But if we push further and ask the following question about the relevant counterfactuals world in which Bert left on his walk a few minutes earlier, would the chain of causes leading to Bert leaving when he did have been different from what it was all the way back through time, or would Bert's leaving for his walk a little earlier have been caused by a miracle, been brought about by a violation of a law of nature? Something goes on in his brain that slows him down a little bit and he leaves a little later. Which would it have been? And one wants to say, well, that question just doesn't arise, right? In terms of what we care about is the causal independence of these two chains. Nevertheless, one might think on a general account of counterfactuals that uses these kind of modal resources, we're forced to answer that question. And that's really the puzzle. What one would like is a way of saying that the problem just doesn't arise. Now, Lewis distinguished what he called backtracking counterfactuals from the standard kind. So a backtracking counterfactual asks, if something had happened that didn't happen, why would it have happened? So we look backwards at the course of events that leads to the event rather than forward to what the consequences of the event will be. And the backtracking counterfactual yields a different conclusion that's not compatible with what's led by the other one. So, about Bert, we could say, well, if he had left a little earlier, it probably would have been because the phone rang, or whatever. I mean, you could say, or because some other distracting event took place. But we don't assume, when we're looking forward to what would have happened at the occasion, we don't look to this causal story. If we do look to the backtracking way and the forward-looking way with actions, we get something quite different. So if I choose both boxes, one can ask, why did I choose both boxes? And I say, because I believe that if I had chosen just one, I would have gotten less money than I am going to get, even though I don't know how much money it is. It's probably nothing, 1,000 rather than nothing. But But I know that I would have gotten more money than I would get. So therefore, I chose both boxes because it would have been irrational for me to choose just one. But if you ask, if I had chosen one box, why would I have chosen it? And I say, well, I would have chosen it because my values and my reasoning would have been different than it is. That I would have been a different kind of person than I am. Or more, in terms of more realistic kinds of decision problems, I could say, two questions I can ask. I can say, if I made a choice, I decided to take the job rather than not to take the job. And you say, if you had decided not to take the job, why would you have decided it? And I say, well, I would have had slightly different priorities than the one I have, and one I in fact have. I would have different values. It still would have been rational, but it would have been rational relative to a different set of beliefs and desires. So if you look in the backtracking way, you're saying the miracle, if there's a miracle, is not somehow I choose against my beliefs, but rather my values, but rather I would have had different values. But if you ask why, in the forward-looking way, why did you choose this? I say because if I had chosen otherwise, I would have acted irrationally. And that's when you ask about the Sly Pete case. Why did Pete fold? Because he knew it would have been irrational for him, because he would have lost if he called and lost more money. So the backtracking way doesn't help us get out of the puzzle about determinism. So that puzzle remains, and of course it's a familiar puzzle anyway, but I think there's some illumination to thinking in this broader context of a puzzle about counterfactual reasoning, and not just a puzzle about decision. There's also an issue, I mean, of course, one can try to defend a compatibilist solution to the problem of free action, but in doing so, one has to sort of address these broader issues. There's also a compatibilism alternative with respect to chance. So that some people think chance, real chance, depends on fundamental indeterminacy, quantum mechanics or something. But of course, the application of chance in science is heavily involved long before quantum mechanics is thought of in terms of statistical mechanics and so on. So determinism seems to be compatible with the scientific application of objective probability, and explaining how that happens is part of the same pattern of problem. Okay, so I'm sorry to go way on so long, but next time we'll look at the general question of dispositional properties, and then look back at the game situation, the decision situation, and look at strategies as examples of a certain kind of disposition, and see if we can throw some light on these questions of the relationship between dispositional properties on the one hand and decision intentions and plans on the other hand. So thanks. Okay, I'm going to start today with some general remarks about dispositional properties and their relation to conditionals and to the projection strategy that I talked about on Wednesday, sort of really expanding on one of the examples of the idea of the projection strategy, namely the Goodman's way of thinking about dispositional predicates. Then, after sort of looking in a little bit more detail at the general issue, I go back to the game and decision theory models that I talked a little bit about, sketched really. I didn't really define the models, but sets the idea of a kind of model of a game, a model of a sequence of decisions. And in this context, see a little bit more specific reflection of some of the general issues, particularly the idea of the game theoretic notion of a strategy, and a way of thinking of a strategy as a complex dispositional property. And the general hope is, I mean, I was saying, I don't have a big, constructive, uniform picture to offer in defense of a way of thinking metaphysically about natural necessity, so much as a family of strategies for trying to get clearer about some of the connections between some of these different notions. And so part of my motivation here is to say there's some very specific problems about practical reasoning, and also some very specific problems in epistemology about inductive reasoning. These specific issues, it helps to illuminate them, to connect them together with some more abstract metaphysical issues concerning the nature of natural necessity. So we'll see something about how going back and forth between these kinds of formal models one gets of different kinds and trying to see how they can be put together, one can at least bring out some we hope some illumination, but in some cases just a matter of articulating and clarifying where the problems are. Okay, so dispositions and conditionals. A dispositional property generally is a property that's understood in terms of the way it manifests itself under certain conditions. So the disposition of an object is directly, closely related to two other properties. So you think of a dispositional property as a monadic property of something, the thing that has the dispositional property. And the two other properties are a manifestation condition and a test condition. However, one analyzes the relationship between these three properties, whether one of them can be analyzed in terms of the others and so on, whatever one thinks about that, everyone sort of thinks of the nature of dispositions as being characterized in terms of these three kinds of properties. So a glass is fragile if it would shatter if dropped, roughly speaking. It would tend to shatter if dropped. It would bend if it's flexible. Then, if it were subjected to suitable pressure, it would bend. It's soluble in water if it would dissolve if put in water. It's observable if it can be seen by a suitable observer under suitable lighting conditions. These are very, in most cases, somewhat vague characterizations of a property. What are suitable conditions and so on, but one generally understands dispositions in terms of things that manifest themselves under certain specific conditions. The examples I give are very different, both in how vague or specific they are, and also how much they're just sort of common sense characterizations of a fairly superficial kind of property, or whether they're themselves theoretically loaded. So soluble is a kind of paradigm people sometimes talk about, but it's a technical, scientific notion. It's not dissolving, is not simply a superficial observable property. It's a particular kind of physical chemical process. And so the very notion of dissolving and solubility are connected to a theory. But many of the others, you begin with a kind of rough characterization of the way a thing behaves, and that's a kind of primitive start on getting kind of theoretical understanding of a process that's going on. In the old philosophy of science literature from the logical empiricist days in the 30s and 40s, dispositions were regarded as the simplest kind of theoretical term. The general problem was, how do we explain unobservable entities and theoretical concepts in terms of observation, observable properties and observable concepts. So the idea is that manifestation conditions are observable properties, although as we'll see, that's not always the case in the more abstract consideration. But since one can't just sort of look at a thing and tell that it's fragile, unless one has a theoretical understanding of what kinds of things are fragile. But it's a fairly superficial problem or property nonetheless. So the idea was that if we have difficulty even in explaining dispositional properties in terms of observation, then how are we going to ever understand more highly theoretical notions? So the starting point, particularly with Carnap, who had a theory about dispositional properties and a way of trying to give them partial analyses, this really is the origin of the problem. But the problem takes on a life of its own beyond the positivist time. Now, it was thought in this early discussion that if we could only understand counterfactuals, then we could define dispositional properties in terms of counterfactuals, simply by saying that the property of being flexible was simply to be defined as the counterfactual property of being such that if it were subjected to suitable pressure, it would bend. So, I mean, that's one of the motivations that Goodman had for looking for an analysis of counterfactuals. But it was taken for granted that, well, if we could do that, that would solve this problem. But then we can't find an analysis of counterfactuals, Goodman argued. So the simple pattern, as I said, of analysis would be, of dispositions in terms of counterfactuals would be, if it passes the test condition, if it had passed the test condition, it would pass the manifestation condition. Something that would be counterfactual in some contexts and not counterfactual in others. So an object is flexible if only it would be subjected to suitable, would bend if subjected to suitable pressure. But then it was argued in a classic paper which was very influential, by C.B. Martin, that this simple analysis of dispositions in terms of counterfactual won't work anyway. And this led to an extensive literature about what came to be called Finkish dispositions. So Martin's example, a contrived example, but there are other situations that might be less obvious but more natural of this kind of thing, was what he called an electrofink. So an electrofink is a device that connects to, when it detects a live wire, that a live wire is about to be touched by a conductor, then under that condition, instantly it causes the wire to become dead. So you have a live wire, you connect an electrofink to it, and it's kind of a protective device, so that if ever a conductor were to come close to the live wire, it would immediately shut the electricity off. So the property of being live with respect to an electrical wire is a dispositional property where the test condition is being touched by a conductor and the manifestation condition is current flowing from the wire to the conductor. The live wire remains live when connected to the electrofink, but it no longer has the counterfactual property. So the idea is it retains its dispositional property. You don't change anything about the property of the wire. It's still a live wire. There's still electricity in it. But it doesn't have the property of being such that current would flow from the wire if touched by the conductor, because being touched by the conductor would have, by the time the conductor got there, have turned off the current because of the electrofink. The potential gap between counterfactual predicates and dispositional predicates was anticipated in a less, in a simpler, straightforward way by Goodman, who gave a simple example of an object which is inflammable, even though it would not burn if heated. And the reason it would not burn if heated is because it's in an oxygen-free environment. The general lesson that Goodman drew was that, as he put it, quote, to speak very loosely, the dispositional statement says something exclusively about the internal state of W, the object, while our original counterfactual, if it were heated, it would burn, is a more general property about the overall situation. So the idea is a counterfactual makes a claim about overall situation, whereas a disposition is supposed to make a claim about a specific, normally, not always, but an intrinsic property of the object. Okay, so while the original counterfactual says something additional about the surrounding circumstances. So it was in this context that, making this point, that Goodman remark I noted on Wednesday, that the problem of dispositions is perhaps the problem of dispositions is really simpler than the problem of counterfactuals, and that we should perhaps approach the former problem first. But this way of approaching the Goodman's way of approaching the problem of dispositions was not, as he attempted to do with counterfactuals, to look to a reductive analysis in general of dispositions in terms of the test condition and the manifestation condition, but rather to instead to link this kind of conceptual problem, the problem of explaining these concepts that go beyond observable concepts, by linking them to the problem of induction, to the methods we used, as I said last time. We talked about that you have the problem of inferring, the problem of induction put in a very simple-minded way, but the problem of inferring from observation to things not yet observed, analogous to the problem of inferring conceptually, extending a property from things that are subject to a test condition to things that aren't subject, perhaps not subject to the test condition. So it's basically the idea of trying to say, well, we got the problem of induction anyway, and all of the various ways of thinking about our inductive reasoning, and even though we can't solve the problem of induction on Hume's terms, what we can do is give a kind of account of what we're doing when we do induction, and the descriptive procedures we find by studying this very general problem of epistemology can be applied to understanding how we project conceptually to get dispositions. So that was the idea, and that's the projection strategy. So the picture, to quote from Goodman, the way he thought of it, this is a quotation in the middle of the first, toward the end of the first page of the handout. Flexes and fails to flex are mutually exclusive, and together they exhaust the realm of things that are under suitable pressure. But neither applies to anything, neither flexes nor fails to flex, applies to anything that is outside of this realm. If it's not subject to suitable pressure, it doesn't fail to flex, whatever it is. So thus, from the fact that flexes does not apply to a thing, that we cannot in general infer that fails to flex does apply. Within the realm of things under suitable pressure, however, the two predicates not only affect a dichotomy, but coincide exactly with flexible and inflexible. Again, idealizing a bit with odd cases where things behave in abnormal ways. So when the dispositional predicate, what the dispositional predicate does, again, still quoting Goodman, is, so to speak, to project this dichotomy to a wider class of things. And a predicate like flexible may thus be regarded as an expansion or projection of the predicate flexes. So that's the picture. What is the basis for this projection or extension of the application of the predicate to the wider domain? Can one, and the idea is one uses exactly the same principles that one uses to make predictions about the future, or more generally, from the unobserved to the unobserved. So again, no analysis here, just saying we have some general methods of solving a certain problem, and we can extend those methods to a different problem. So again, as we did, we contrasted the projection strategy with the reduction strategy that guided Goodman's original project, and that also guided David Lewis's approach to counterfactuals that we talked about. Dispositional predicates are taken as primitive, and Goodman would have insisted we don't have partial definitions, even though in a sense there is a kind of partial definition here. We have to take those as postulates and introduce just new primitives, but justify the introduction of those primitives by the way we use inductive procedure to tell that they are present. So the project is to explain how we can have evidence about their exemplifications, that is, about the presence of a dispositional property. They are like the objective properties that De Finetti explained, although De Finetti didn't believe in such properties, but he provided the resources for applying the projection strategy to the concept of objective chance. You can't observe objective chance, but the conceptual connection between chance and subjective probability that's brought out by De Finetti's mathematical result explains how one can have evidence based on observation, namely on the actual flips of the coin, whether they come up heads or tails on particular flips, how those can be seen as a kind of manifestation of the disposition, which gives you not certainty, but probability of in a very precise way, the hypothesis that some chance property is present, that the coin has a bias of 2/3, can be confirmed to as high a degree as you like as you gather more and more evidence. And that's sort of a corollary of the theorem that he proves, that you will get confirmation of these empirical hypotheses about dispositional properties. So then if we can vindicate dispositional properties in this way, then they'll be available as a resource for characterizing the relevant notion of comparative similarity or minimal difference that will give us a substantial account of counterfactual dependence. But they also rely on an implicit hypothesis about independence. So that's why they're not reductive. So it's essential that, the idea of a disposition is that the test condition, whether the thing is put under pressure or not, that's a sort of local property that an object has at a certain moment, and that having that property or not is under normal conditions counterfactually independent or causally independent of whether the disposition is there. So that's why the Finkish idea is an idea we can artificially introduce a counterexample to the independence, but the independence is still playing a central role in the theory, because the reason it has the disposition is that normally you don't take dispositions away when you put something under the counterfactual conditions. Now, Goodman was a minimalist who was happy about a skeptic about intentional notions such as properties and relations. But he was happy enough to talk about predicates and their extensions, but not about properties. But this is a hang-up that we can separate from his projection strategy for explaining dispositions. So one who's more friendly to properties might put the point this way: we find a distinction, things shatter or they don't, that is manifested under a certain test condition when they get dropped. We hypothesize that there exists a property that coincides with the display property normally whenever the test condition is met, but that things have or lack independently of whether they satisfy the test condition. The test and manifestation conditions are then used to fix the reference of the hypothesized property. So it's the property, if there is one, which explains why things shatter when they break. Now, the hypothesis is an empirical one, as reference-fixing stipulations always have an empirical presupposition if they're empirical. This attempt to fix the reference may fail. As we saw, we talked a little bit the other time about the alleged or hypothetical hypothesized property of being lucky that a person might have. And the idea that really the empirical hypothesis is there is some feature of the person that have independent of their engaging in chance events like buying lottery tickets, which lead them to be successful. It's like having a greater chance of winning if you're a lucky person. But the hypothesis that there is such a property is not borne out, because if the hypothesis were correct, then you can assume that you would be able to find other properties that tend to correlate with it empirically. So then that would give rise to further ways of establishing that the property is present. And it would lead to sort of theoretical building on the hypothesis that the property exists or is instantiated. When you try that, sometimes it works and sometimes it doesn't. Sometimes it leads theory, but it's not. There's no algorithm for telling when it works. It's a matter of making empirical hypotheses, putting them together with other theoretical hypotheses that you are inclined to accept, and drawing conclusions from them, and either getting things confirmed or disconfirmed. So a very general way of thinking about the intuitive picture here is something like this. If we look at just the surface of things, just try to be extremely descriptive about what you see in the world without any theoretical assumptions at all, what you will find is a seemingly chaotic sequence of events as things interact with each other. The theorist hypothesizes that the things that are interacting have certain underlying, more stable, persisting properties, even though everything keeps changing in the world as we look at things. And that there are certain properties, perhaps underlying and unobservable properties, which persist through this and help to explain why the interactions, chaotic interactions, are as they are. So there are properties that are more stable and independent than the overt behavior of the interacting things would suggest. When two or more things interact, the behavior that's manifested will depend on the underlying dispositional properties of all of the things. And the test conditions for the dispositions of one thing might make reference to the dispositional properties of other things, in particular with the things they interact with. So to use a familiar kind of example, a key is disposed to open a certain kind of lock. What kind of lock? The kind that is disposed to open when by that key. Now this particular description of the dispositions is entirely circular, but it nevertheless is correct in terms of identifying a feature of the lock which it has independently of the existence of the key, although of course, since it's an artifact, it was designed to fit the key, but the actual physical base of the disposition is something the lock has independently of the properties that the key had. It's because of the relationships between the two more stable disposition properties that they tend to interact as they do. Now it's obvious there's no analysis here, but there is a non-trivial hypothesis that helps to define the explanatory project of determining the character of the relevant properties of the separate components of some system. So any kind of sort of theoretical approach to understanding how some complex system works will involve separating the parts and saying what is it about this part and this part that makes them work together in the way they do. Now dispositions come and go. While manifest conditions are extremely local, dispositional properties aren't something that something has forever or essentially, or they needn't be. A thing may be disposed to acquire or lose a disposition. So we get a kind of hierarchy here, a potential hierarchy of more complex dispositions which when they have a disposition, they're disposed to get another one or something like that. So the manifestation condition for one disposition might be the acquisition of another disposition. So I once saw a very neat experiment, demonstration of some properties of super cold objects. You put a banana in a liquid nitrogen thing and super cool it, and took it out and dropped it on the floor. It's shattered like a glass. Okay, so a banana normally is not fragile, but it is disposed to become fragile and therefore disposed to shatter when dropped if it's supercooled. An ice sculpture is disposed to shatter when dropped, so it's fragile, but it's also disposed to melt more slowly when heated, and when it's heated, it loses its fragility as well as its shape and various other properties which are not far from being dispositional properties themselves. Now, the finkishness of dispositions in a certain contrived situation, that is the phenomenon that demonstrates the inadequacy of the simple conditional analysis, is just one kind of example of the complex interaction of dispositional properties. So the general pattern of a Finkish disposition is something like this. Property D1 is the property of being disposed to manifest property M in condition T. That's the disposition of being a live wire. D2, a second dispositional property, is the property of being disposed to lose D1 under the same test condition, the condition of being, or at least the imminence of the test condition comes a little bit before. So D1 is a Finkish disposition. This is the more abstract characterization. D1 is a Finkish disposition of an object that is if it also has a dispositional property D2, the property to be disposed to lose the first disposition. In the standard examples, the D2, as in the C.B. Martin's example, D2 is an extrinsic property, not an intrinsic property. It's something outside that's detached to the live wire. But it could be a separate but still intrinsic dispositional property. Finkishness, along with other patterns of interaction, there are lots of examples in the dispositional literature of different kinds of masking properties and antidote properties for dispositions like being poisonous and so on. These other patterns show that the stability and independence conditions that the dispositional hypotheses are aiming at is relative and defeasible. So you can lose the independence if you're put in a certain kind of situation. When a disposition D1 is Finkish, then the test condition and the property are not because of the Fink, independent. But the notion of counterfactual independence still plays an essential role in the characterization of dispositions. It's essential to an example of a Finkish disposition that the two dispositional properties, the D1 and the D2, the disposition to do it and the disposition to take away the first disposition, are independent of each other, at least in the sense that it makes sense to suppose counterfactually that the thing has the one property but not the other. If you try to construct an example of a Finkish disposition where the two D1 and D2, the two dispositions, are realized in the same underlying property, then it won't work. You won't be able to find it. Now, okay, so that's the general remarks about dispositions, about the strategy of trying to develop a particular theory for a particular context in which you talk about dispositional properties. And so now I want to look at the kinds of a very special condition, namely a particular kind of application where one might carry on this kind of explanation of what the dispositions are. And that's the kind of structure that represents a decision situation. So you can see a game is a representation of a complex interaction. The game might involve some chance moves. It might be that you flip coins or you deal cards at certain stages where the chances of the various hands that you get in the cards are what known and specified in defining the game. And then the players get their hands or whatever they get, and they then make various moves in sequence responding to each other's actions. So you have an interactive process, which is, again, what the game theory provides is a very highly idealized representation of this interactive structure. In trying to articulate that structure and to explain the causal interaction, one one way to do it is to introduce various dispositional properties which will be manifested when the time for action occurs. So an agent or a bunch of a class of agents, finite set of agents in a game, each have various dispositional properties. And the dispositional properties they have will be of several different kinds. And one of the things I want to do is look at in the final part is to look at the relationship between different kinds of dispositional properties of an agent that go into explaining why the agent does what he or she does. So in characterizing a decision problem, you give degrees of beliefs and credences, numerical or measurable propositional attitudes, both of quantized versions of belief and quantized versions of desire or valuing, motivational states. Probability represented in the formal theory by probabilities and utilities, and those should be thought of as dispositional properties. When we move from the extensive form of a game represented by the tree structure that shows in time the interaction of agents, to the more abstract but simpler strategic form of the game, we are moving to a more to a more extensive dispositional account of the relevant features of the game, the people and the chance moves that get made. So the idea of the strategic form intuitively is that the way in the idealization, the way that everybody is disposed to behave at the beginning of the game will determine what they do as the game proceeds. That is, they have dispositional properties at the beginning, and those are successively manifested or not. Some of them are not manifested, but when the circumstances arise, that will have an effect on altering the dispositions, in that when you learn new things, you believe new things. Your credences change in the course of a game, but the idealized theory assumes that the way your beliefs change in the course of a game are determined by your dispositions to change your beliefs in certain ways, namely by conditionalization, at least in the case where the thing you learn is compatible with what you previously assigned probability 1 to. So you have a kind of assumption of conditionalization, which is a hypothesis about how attitudes for a rational agent, for a fully rational agent, change in the course of a situation where one of the events that happens is the requiring of evidence. Games make highly constraining assumptions, which, in the original game theory, which once you get on account of the kind of models of games we have, and once we've introduced beliefs, structures, and probabilities into game theory, it allows for further generalization. In the game theory as it is, in all the standard games, it's assumed that utilities stay the same throughout the game. The utilities come at the end. So the utilities are you play your game, and then you get a payoff at the end. But realistically, you can have a situation where the values that you have may change in the course of a game. And if one had some kind of systematic theory of how they change, then you could introduce that. And the fact is that Bayesian decision theory does give us a systematic, mathematical, precise theory of how rational belief changes as one receives evidence, but we don't have any theory about how values change. So the assumption is the values remain the same. And there are various artificial ways of trying to introduce changes of utilities, but you could do it more directly. And I think this actually, if one actually looks at some of the potential applications of game theory, ways in which beliefs change will be very important for strategic reasoning. If you think in general, what goes on in a negotiation, in a strategic interaction, in a discussion, or even just the interaction between people walking down the street. I mean, there's a tendency, this is a purely empirical speculation, but it seems there's a tendency for you to think of the people you're interacting with as friends or foes. That is, a game where there's lots of common interest is got a certain stability to it, and where there's a certain pure conflict of interest, the game has a certain stability to it. And we tend to gravitate toward those things. So as you interact, if you are my friend, if you cooperate, you help me, then I have a tendency to reciprocate. Now, part of the reciprocation in games is familiar and explainable in the resources of the theory, because there's tit-for-tat kind of strategies where I may punish you in the future because you punished me in the past. And so there can be a purely strategic reason for changing for cooperating in a situation with which a person with which you have conflict. But it also can happen that I am less inclined to take your values seriously as things that I should respect if I regard you as my enemy, right? And if you cross me, and people want revenge, they want to hurt someone for its own sake, because I tend to go to a more sum-zero kind of way of thinking. So there's psychological reasons which might be partly explained by the dynamics of valuation, which go beyond the simple strategic form of reasoning. But in any case, the idea is one has an interaction here, and one wants to explain the interaction in terms of the dispositional properties, allowing for the fact that dispositional properties themselves are subject to change, because there are dispositions to acquire and change dispositions in systematic ways. Before getting to looking at the game, the idea of a strategy, I wanted to introduce one further structural property of dispositions related to Finkishness, which will come up. So here's a kind of property a feature of a complex dispositional situation. Imagine that we have a electrical system with a fuse, and in addition, a backup fuse. The first fuse is disposed to break the circuit, as fuses do, when the circuit is overloaded. So the test condition is overloaded circuit, too much current. The manifest condition is breaking the circuit. The second fuse, the backup fuse, is disposed to break the circuit if it's overloaded and the first fuse fails. So imagine two fuses wired in series, where the second fuse will never be broken, assuming the first one works. But still, these are separate things, so one can understand this complex structure, even though the whole system is set up so the second dispositional property is never manifested because the test condition is never met. But since everything is defeasible, you could imagine it could happen that the first one would fail. A second example of this kind of structure, consider a slow-acting vaccine that's disposed to protect the patient. This is a very ineffective vaccine. Protect the patient against the fast-acting killer virus. The virus is disposed to kill the patient before the vaccine takes effect. But the vaccine is disposed to prevent the patient from dying on the assumption that the virus doesn't kill the patient right away. So we have, again, two dispositional properties, one of which is manifested only if the other one fails. Okay. Again, it's essential to the existence of this kind of pattern that these two properties be in some way independent of each other, in that one can understand what it would be for the thing to have the one but not the other, or for the one to work and the other one not to. Okay, now the games I talked about last time were interactive sequences, and we make the move to the strategic form, represented by a matrix, which represents the situation as understood before the game starts. And the idea is that if the game were to be played out in real time with the actual interaction, assuming the agents are perfectly rational, will change their behavior in the way in which the disposition suggests, the rational disposition suggests they will, then the outcome of a rational choice in the strategy situation will be the same as the situation would be if the game were played out. So we represent the dispositional properties of the players at the start of the game. And you can think of them as dispositions which actually are manifested not in the playing of the game by handing the referee the strategies, but rather by actually just playing it out in real time. Now, in our models of the game, the types of the player, that is, we define the dispositional properties of the player with their types by saying what their prior beliefs are, and perhaps also what their dispositional or what their belief revision policies are, which are again another kind of disposition which extends conditionalization. So you can say, suppose you learned something which in fact has probability 0 for you. As you were to learn, you assign probability 0 to some proposition. That is, you say, I'm certain that my opponent will not choose option L. And then it turns out my opponent does choose option L, to my surprise, and I learn it. So now I have to revise my beliefs, and I can't conditionalize because I assign probability 0 to this. But I can have belief revision policies, perhaps represented by a lexicographic, more extended probability system. I can have properties, belief revision properties, which tell me how I change my beliefs when I learn this surprising information. Okay, so the beliefs and desires and the belief revision policies are a certain kind of mental disposition, but a strategy is a different kind of dispositional property. So a strategy is thought of as a kind of conditional intention. So strategies are not identified with something that has to do with utility. Utilities and probabilities motivate you to choose a strategy. They motivate you to make a plan a contingency plan, perhaps, to do certain things under certain conditions. But simply having a desire, even, that is, for something to have much higher expected utility than something else, is not itself, by definition, it isn't a decision to do that other thing. So the idea of decision theory is that an action, while it's motivated and perhaps even determined by your probabilities and utilities, if you're rational, it's itself something conceptually independent of this. So the two very different kinds of dispositional properties that play a role in a unfolding decision theoretic situation. You have the things that make your decisions rational or not, namely, according to the theory, namely the values that you're trying to achieve, and then there are the decisions which either are rational or not. But it's essential to the game situation that you have the capacity to do any of the things, to perform any of the actions that are available, to follow any of the branches from the choice point that you reach. So a strategy is a complex intention. It represents conditional intention. What will you do if this choice point is reached? What will you do if that choice point is reached? And so on. So to have a strategy is to be disposed to act in those ways. Now, even if there's a very clear distinction between what you want and what you do at the moment of choice. So you say, I'm deliberating and I figure out that the rational thing to do is to choose option L rather than R, and then I say, therefore I do it. And that's a further move. But forming an intention which brings with it a belief, that is if you intend to do something, then you believe that you will do it. And yet, you can form an intention, and that is not a decision. That's not doing it, right? That's only because maybe it's in the future that you will execute your intention. So an intention falls somewhere between a kind of property that you find yourself with. I mean, you say beliefs and attitude are in some way kind of passive. They're there. I notice that I have these beliefs and values. But actions are things you do, and there's an epistemological connection which is central here, which is that in the case of intention and decision, you know what you do in virtue of deciding to do it. So I don't have evidence. If I say, I'm looking at the thing and say, am I going to have a ham sandwich or a salad at lunch, and I know that I'm going to have the ham sandwich because that's what I've decided to do, right? And I don't have evidence that that's what I'm going to do. I have a decision. So it's sort of very emphasized by philosophers like Elizabeth Anscombe and Stuart Hampshire and David Velleman later and others, that a distinction between knowledge by decision and knowledge by discovery. Both play an epistemological role, but forming a plan about what to do in the future is decision-like, but defeasible in that it's subject to execution when the time comes. And so there's special properties of that. But a strategy is a kind of conditional intention. Okay, so I wanted to make just a connection between the notion of a strategy and one of these complex properties that arise in the interaction of dispositions. And this is on the. Before we get to that, let me just say. If you have a notion of strategy, you can define, or you have a model for a game, you can define rationality in several different ways, some more stronger, some stronger than, one stronger than the other. You can define a player's play in the game as being rational if every action they take is rational. So you can first of all define the rationality of an action. It maximizes expected utility. The property of a whole game, a player in a game, is rational if the player, every choice the player makes is rational. But a stronger notion, that's sort of what Robert Aumann called material rationality. Substantive rationality is the property not only is every choice you make rational, but every choice you would make would be rational, every counterfactual choice. So you can imagine a situation where somebody's drunk at the party and I take their car keys away so that they can't drive home. This person is such that they would have, being no longer fully rational, they would have driven home drunk if they had had their car keys. But I perform a preliminary action in the game, namely taking the car keys away, removing the option that the other player has of driving home. So it turned out the other player was rational in the material sense. Everything they did was rational, but they weren't substantively rational because they would have done something irrational if they had had the chance. So you might think of this person as having a strategy, which was drive home if I can, a conditional intention to drive home if I can. That occasion didn't arise. That node of the tree wasn't reached. So therefore, the person was prevented from acting irrationally, but not thereby from being irrational in the stronger sense. Okay, now, in that light, we can make a distinction between two things that might explain why you don't reach a certain node of the tree. So it might be that you don't reach it because the other players don't make the moves which would take you there. So I say, I don't know for sure whether I'm going to get to this point because I don't know whether earlier moves in the game will allow me to make a certain choice. But you also can be in a situation where I know by decision, that I am not going to reach a certain node of the tree. So just to illustrate the example, and this is the one bit of graphics that I managed to get into the handout. We have two moves. This is just to illustrate the point. Think of this as a one-player game. And this is the utilities that are achieved. By each move. Okay, now there are, in this game, 4 strategies. There's the strategy, choose L1 from this node, and choose L2 from that one. There's a strategy L1, R2, R1, L2, R1, R2. The first 2 strategies I mentioned are purely counterfactual strategies. They are strategies that say, choose this, in which case you yourself know by decision you're not going to reach this point. But a full strategy still has to answer the question, what would you do if you did reach that point? So one distinguishes a full strategy of this kind from a plan. A plan is like, there are only 3 plans. Choose L1, that's the end, or choose R1, L2, or choose R1, R2. So a plan is a sort of truncated strategy that eliminates the purely counterfactual ones, the things you know by decision you're not going to do. So the idea of deciding what to do if you don't do what you're going to decide is what you need to do to have a full strategy. So the observation is that this has the pattern of the backup fuse. Right? It has the pattern that here you have an element, a dispositional property, a dispositional conditional decision, which will be reached only if your dispositions overall are not reached. So first disposition to choose L1, second disposition to choose R2 if you reach this point. So I might ask, what point would there be in having full strategies rather than simply plans? And it's connected with the issue with the dispositional property. You have these kind of patterns of disposition only if the things are somewhat independent of each other. If you want to reduce rationality to the rationality of individual actions, then you need to think about strategies. So if one asks, suppose the agent chose L1, was that a rational choice? And the answer might be, well, that depends on what the person would do if they had chosen R1. Because the person who chooses L1 over R1 is saying, what's the expected utility of this, and what's the expected utility of that? And in order to determine the expected utility of that, you have to answer what's the expected utility, what's the probability of this different choice. So you say, suppose the agent says, the reason I chose L1 is because if I had chosen R1, I would have chosen L2. So I got 1 rather than 0. And I say, why would you have chosen L2? I say, well, that would have been irrational. But that doesn't make this action rational. It makes only this action rational. So if you're interested in trying to explain the rationality of an agent in terms of the individual choices, then you want to talk about pure, full strategies. But a more straight, sort of natural way of thinking about it is to say what you're doing at a point like this is making a choice of a plan. And a plan is rational because you can now decide what you would do at this point. You don't have to just predict what you're going to do at this point. You can decide. So if you're at this point and you're deciding that you're going to choose this, then you're making an irrational judgment at that point. So you can say there are 3 plans, this, and that. This is the best one, this is the second best one, and this is the third best one. But therefore, it would be irrational to choose this one rather than that one. So there are examples in the philosophical literature about cases where, there's the famous example of the procrastinating professor who was asked to review a book, and the best choice is to accept and then review it. The second best choice is to decline, and the third worst choice is to accept the review and never do it. And the professor says, well, I'm really never going to do it. So the rational thing to do is to reject, to decline the review, and saying, well, I would be irrational or morally weak or something if I made this other choice. So there's a rationality involved somewhere, but not this choice. This choice is the right one to make. So those are the kinds of situations. So there's just a general point. There's a connection here then between, first of all, whether you should think of yourself and your future and your planning as an agent deciding not just what to do now, but what my overall situation is, or should you think of your future self as another agent, as something subject to prediction? Realistically, you should be somewhere in between, but the game theory idealization assumes this doesn't make it accurate, but it also doesn't make it a wrong kind of idealization too, because it helps to bring out the issue of the role of this distinction between decision and prediction. It's clear enough in this case that if this were a second agent where we have a common interest and the other agent also is going to get 2 this way and 0 that way, then my first decision is based on a prediction about the other agent. I think the other agent will act irrationally, therefore the rational thing for me to do is to do that. But if it's you yourself who's the other agent, then it's not so clear how to think about the problem. Okay, well, I managed to run overtime every day now, I guess, but for that reason maybe I'll stop. Thank you.